Good evening, everybody. It's Mike from Faraday Research. It is Friday night, 9 o'clock Eastern. It's March 15th, 2024. Welcome to the show. And yeah, we're going to have something interesting tonight. I wanted to show for a little while. Just bear with me for 1 second. Sorry about that, everybody. Yeah, I just had to shut the volume off on the TV. Uh, yeah, I had that on, and I actually got the show streaming live on the TV, so I can kind of get an idea of how things look when I'm actually broadcasting. So I tried the little thing, did my intro there. I tried a different method on showing it because for some reason StreamYard won't accept the audio that goes with it. So that seemed to be an issue. So I figured out a different way of going about it. So, anyways, it's kind of been a busy week. I've done a lot of 3D printing. I've been working on the Renegade device. Oh, hi, Tivon. Welcome. Glad you can join the live stream. Yeah, so it's been a busy week. I finally got over this bronchitis that's been like killing me for the last probably, I'd say, a month. So I'm feeling a lot better. Um, I don't have that cough in the chest anymore. That's gone. So I finally got some. I went to the doctor, got some medication, so it seemed to have cleared up the infection I had. So I'm feeling better. I posted a couple videos this week. I redid the Renegade device. Just see here. I want to maybe show one of the. Let's see what we got here. Yeah, so I did two. Um, I believe this week. Yeah. Oh, and the other thing too is I forgot to mention. Uh, I'm right at the cusp of hitting 3,000 subscribers. That's amazing. I'm so happy. Like it's taken a long time to get there. So I'm at 2,960 subscribers to the channel. I've currently got 421 videos. So there's lots of information. It shows you the evolution of my learning and my understanding of electricity and how I kind of started with a non-biased approach to it. So it's taken a lot of time to learn this stuff. It's because I don't have electrical background. That's not my forte. Uh, I was a machinist for many years, but never into the electrical stuff. So hopefully, I'll have Mike on tonight, and hopefully, maybe even Gerald will pop in. Um, I do have some stuff I want to show. We can get into that. Now, the one thing is, for the last while, I've been working on the Renegade device pretty much, I would say, realistically speaking, about 8 years. And it's taken me a long time to get where I got. So, what I want to do is get it validated. Now, it's kind of funny, people you meet over the years that will kind of lead you to uh, uh, an opportunity or a friend through a friend where you're going to be able to do some work with or you get your system validated. So I spoke with John Hutchison the first time I believe it was in March or April of 2006. Now, years ago, in 2006, podcasting was pretty much in its infancy. Ah, Mikey. Yeah. Well, don't worry about Mike. We'll get into that if you want to join the show. Uh, yeah, join in if you want. I got some stuff I want to show tonight. Um, so going back to what I was saying, I have to get the device validated. And I spoke with John Hutchison back in 2006. Back then I was into the conspiracy radio and all that kind of stuff. And so I started a podcast, and lo and behold, we were able to get John Hutchison. This is going back 2006. We're going back quite a ways here. So we actually did two shows, I believe, with them. We had one show and then we did a second show with them. And I have to hand it to John Hutchison, because if it wasn't for him, I don't think I'd be doing the stuff I'd be doing today. I could really give him props on that, that he was a huge influence in me getting into this stuff. So watching his free energy stuff, his Tesla stuff, his anti-gravity stuff, it was it was really profound to me, and it really inspired me. So I can hand it off to John Hutchison, because I've been following him for years, over 20 years. Seen him on the Science Channel. Um, what was it? The back then it was the Science Channel, Sci-Fi Channel. All these channels I've seen his videos, and that's pretty much how I knew of John Hutchison at the time. And then lo and behold, a few years later, I actually got him on my podcast twice. So after talking with him, he was just completely, utterly fascinating. So he worked with a guy back in the early 1980s named George Hathaway. Now, George Hathaway is an electrical engineer. He was, I believe, a professor. Actually, we'll get into that in a minute, but he was a professor of electrical engineering at the University of Toronto. He's been there for years. So he has now his own private institute called Hathaway Research International. And it just happens to be that his laboratory is about 30 minutes from where I live, basically in the next town. And I'm like, oh my God, like, this is awesome. So I start going over his website a while back, and I start going over his website again. And he invites people who have energy devices or any gravity stuff or whatever, that private inventors, if they want to go there and see if what they have is tangible or real. I'm getting very close with the Renegade device to go see him. And maybe in the very near future, I'm hoping before the summer, that might actually become a reality. I might actually go and see George Hathaway and his crew. And maybe, who knows, maybe I can get this thing validated. And if it is what it is, and I'm I got a reputable engineer to actually look at my device and say, yes, Mike, this is real. So it'll go from there. And obviously, I'm going to ask him, well, where can I take this? Like, what's the next step? So I will have like probably a huge list of questions to ask him. I'm also maybe possibly, I don't know, because it's a research institute, I don't know if I would be actually able to film in there. I would like to actually documentate on camera, if I could actually, you know, film the entire thing while I'm there, right? So if that's the case that I can, that would be awesome. So, oh, we got Mike here. Let's see if we get Mike on board here. Mikey, Mikey. Are you there?
You hear me? Oh, yeah,
I
I'm
can
getting
hear
the
you.
camera, man.
How's
How
it
you
going?
doing, Mike?
Oh, pretty good. Been a pretty productive week.
Right on. Just trying to figure out the settings here.
Yeah, I can see. Just been dabbling with some of the settings here in StreamYard, so to try to make it a better show. I want to show something to everybody. So what I want to do is, I don't know if you were listening earlier. What I want to do is eventually get my system validated. And years ago, I met John Hutchison online. I actually did podcasts with him twice back in the early mid 2000s, 2006 timeframe, and he was the guy who pretty much got me into this stuff. I could really hand it to him to be a huge influence on me getting into this stuff. So lo and behold, he worked with a guy back in the early 80s when he was doing his anti-gravity stuff, uh, George Hathaway. He happens to have a research institute about 30 minutes away from my house. Hathaway, Hathaway Research International, that's the name of his company. He does stuff for all the big aircraft companies, R&D stuff, anti-gravity stuff. He does all that stuff. Now, the best part about it is on his website, which I'm going to show in a few minutes, uh, that they invite inventors. Oh, he dropped off. He disappeared. What happened? We lost Mikey. Come back, Mikey. So, oh, there he is. See if we can get him back on here at the stage. There you go. We lost you. Okay.
Yeah. Sorry.
It's okay.
Go ahead.
Computers glitchy. So on his website, it says basically, if you're an inventor or whatever and you want to get a machine validated, you can go see them. This is George Hathaway's research laboratory, which is about 30 minutes away from where I live, which is awesome. Now, he's an electrical engineer. He's been, I believe he taught at the University of Toronto. He's got a lot of real engineering background. So if there's one guy to test my device and get it validated by somebody, it would be him because he's got some of the old Hewlett Packard testing equipment that they don't even make anymore. And it's a very foolproof, concrete proof way of
Isn't
detecting.
Hathaway he invented a battery or something? Was
No, he
lithium?
worked on it. No, he worked on that with Hutchison, I believe, as far as I know. Hutchison's been working on the crystal power cell for years.
What's the guy's name who invented the lithium battery? Goodwill or?
Oh, I'm not sure on the history of that. I really don't know. I know some history on certain people, but lithium battery is not one of them. I think we're going to have Bernie on later. He says he's not too far away. Let's see.
I'm not familiar with George Hathaway. I know the name. I mean, I've heard the name a lot.
Yeah, I can share my screen and we can take a look at his website. I could kind of read you his bio. Hathaway Research Institute International. Yes, we're going to go share
What's
screen.
his research focused on?
Quite a few things. Okay, so let's go on there. Let's go to his site. Can you guys see that all right?
Yeah, I see.
Okay, so it's Hathaway Research International, our services. I'll just kind of read what it says here. Two major, sorry, scrolling here. Two major service areas are offered. If you are an inventor, scientist, or engineer, has a breakthrough idea but cannot find a suitable facility to perform necessary tests or the funds to support such tests, HRI will examine the concept and determine the best way to verify claims of the inventor. If an inventor is presented with an invitation that he or she deems worthy for further independent investigation, and they cannot find any suitable laboratory to vent the concept, HRI can step in. So Let's go. Find his bio here. Just hold on. Trying to find services. HRI. Affiliate legal. Oh, there we go. Stat bios. Hope everybody can see this on their screen. All right. All right. So George Hathaway. George Hathaway, PE, graduated from the Department of Electrical Engineering at the University of Toronto in 1974 and is a registered professional engineer and founder and president of Hathaway Research International. He is responsible for scientific and engineering hands-on project management from concept from the concept to completion as a chief designer with final oversight and accountability um, with management and direct multiple projects simultaneously. He is a consultant on novel exotic materials, energy production, and propulsion concepts, instrumentation, is an expert in design, analysis, testing, measurement, report writing. George is also a machinist, providing invaluable insight into the fastest route to product development and an expert in scientific and engineering measurements and their misuses. He is also reviewed several scientific publications and an author of a book, Mind Bending, the Hutchison Files. So there you go. That's George Hathaway. So this is the company I'm going to hopefully get my Renegade device validated to see if I'm actually onto something, if it's actually valid, and if I can get a real quote unquote electrical engineer to actually validate this stuff. Let's see, research, current projects. Okay, so they're working on Agnew anti-gravity and nuclear entropy.
Well, I mean, I'm an electrical engineer. You can always ask me.
Yeah, but you're in Florida. I need somebody local.
Oh, you mean hands-on?
Yeah, like hands-on. Actual
In the real, okay, in the room, right?
Well,
Gotcha.
the thing is, he's got this old Hewitt Packard machine that will actually show if it's over Unity or not, and they don't make that machine anymore. And he is one of a few people who actually have that machine in operational condition. So he can do the testing with that device. I forget the name of it. It's a Hewitt Packard.
It's not too hard to, it's not too hard to spot out efficiency in circuit designs.
That's true, but this one here uses a resistor submerged in a liquid, and it's actually taking readings off temperature variation. So I guess it would probably show true COP values.
Oh,
Yeah,
yeah, but you can still, you can still look at the circuit and see, compare it to other circuits,
Irregardless, this guy is literally 30 minutes away from where I live.
Oh, really?
Yeah, that's the crazy.
His lab is 30 minutes away.
Yeah, literally 30-minute drive from my house. I know exactly where it is, and I've worked in that area for years and never even knew. Like, I never even seen a sign outside Hathaway International. So here's some of the projects he's currently working on: anti-gravity, anti-gravity, nuclear entropy, biocommunications research experiments, beryllium commutation monitor, camel beryllium commutation monitor, DARPA, confluence high voltage experiments. He's got contracts with DARPA and Lockheed. I believe he's got some pretty big contracts on the go.
Sounds like he's a busy guy.
He is, and he's an older fella now, so and he's still going at it pretty strong as far as I can see. Energy extraction. Let's see what this one is, just out of curiosity. Oh yeah, he's doing some energy experiments from Casimir cavities. So he's actually doing some Casimir effects. So here's one of his devices that he's working on that actually does the Casimir effect. To
Okay,
actually
now I'm
show,
starting to remember. Now I remember where I heard of him.
yeah. So he's doing real Casimir cavity effects of basically 0 point energy. Uh, let's see. Let's read the description here. Based on the theoretical work of Bernard Hosh and Garrett Model of Colorado, HRI is designed in hosting an experiment to determine whether energy can continuously be extracted from a quantum vacuum field by flowing gases through a Casimir cavity. The
Hmm.
patent concept suggests considerable radiant energy may be produced by gas streams. Those electrical or electronic orbitals are modified in the cavity where certain quantum vacuum modes are suppressed. When the gas exit the cavity, the orbitals and restored by the ambient or non-compressed modes. So yeah, he's got a device. Obviously, he's got a pretty elaborate Casimir cavity. Um, so yeah, this guy is real engineering, and he's got the funds. He's got the backers. He's got investors that are forking out money into this stuff. So yeah, that's really intriguing. I really want to meet with him or at least try to get my device validated, right? It just make things so much better for me to say, okay, what I'm doing is right, and I'm not like full of myself. You know what I mean? And I'm actually doing something that actually has some scientific merit. You know what I mean? So
Yeah, I mean, I can't think of how else to tap off of a Casimir effect other than putting your plus and minus on the two plates.
well, it's real R&D. You can see it right there, the apparatus that they're using, and it looks like he's got a full shop. He's got a full machine shop. He's got a laboratory. He's got some people that are experts in material sciences. So it seems like he's got a pretty elaborate um, thing going. Let's see some of his past research. Um, electron,
Maybe
cyclotron, copper
maybe
unity,
inject
energy
sound
reduction.
frequencies between the two plates.
Oh, I don't know. I would have to ask him on that. So
If I
he's
were to
going
do an
back.
experiment with Casimir, that's what I would try first.
So according to this, his first R&D project was in 1989. So we're going back quite a few years here. Holy
Mhm.
cow. 89 and right up to the present. So yeah, he's been working on some stuff for a
Is he
while.
trying to extract energy from the Casimir plates
Yeah, yeah. As far as I understand, what
or the Casimir setup?
the Casimir setup is where that force is being created, right in between the two plates, and I guess they're injecting gas into it to actually try to extract some energy out of that.
Gas. Yeah,
Yeah,
I would have said sound waves or something like that. But gas is another one too.
yeah.
Or
So
maybe light beams like laser, like light
mhm,
frequencies, the colors, different color frequencies of the light spectrum, and put
yeah.
it in
So
between the two plates. See what happens to the plus and minus on the two
okay,
plates.
1990, they were doing some the Agnew anti-gravity by nuclear entropy, gravity modification theory. That was in 1990.
Entropy is like when everything's like falling apart, right?
Yeah, 91, they did in-house test of the high
Why don't they just
electrostatic
call it nuclear decay
and
instead of entropy? Isn't that the same thing?
well, I guess, well, it's just how they word it, right? What
It's
else?
nuclear decay. That's the old word, the old way of saying it. The half-life.
Yeah, yeah. There's several different, you know, uh,
They keep coming, every few years they
terminologies.
come up with a new word to just drop
Well,
in the
because
bucket of
yeah,
confusion.
well, it's not that. I
It's
think
like
they would.
intentional, isn't it?
Well, I kind of, well, you would think that, yeah.
It
But
builds more idiots. It creates more idiots.
well, I
All
think
these
it's
words
more
they
like,
gotta remember now.
well, they want to create a name that basically reflects what they're doing. So
Virtual
if it,
idiots, not
yeah,
real idiots. They just look like idiots because they don't know the new word that was created.
yeah,
Entropy. How old is that word?
it's been around forever, as far as I
Yeah.
know. Another one they worked
But I
on
don't
that,
think it was used in science until recently. That's what I'm saying.
yeah. Well, see, because of the internet too, has kind of changed everything. All these words and
They used to call it
the,
decay rate or
yeah,
half-life.
yeah. That's back in the early days, early 1900s, 1920s and
Now, if
30s.
you want to sound sophisticated, you use words like entropy and that's
Another project they worked on is I can't pronounce the Podkalinskov spinning superconductor gravity experiment. Potential investors showing null results
I
and
mean, the entropy one
various
got me. I tell you that. Got tell you that. It really got me for a while. Entropy threw a loop,
entropy.
threw me for a loop. But it's basically decay rate or half-life.
Yeah,
When you're speaking nuclear entropy, that's the decay rate of the nuclear, whatever
yeah.
the radioactivity of the nuclear isotope.
No, they
It
did some
decays.
development. They did some development on the electrical bicycle gearbox for the University of Toronto. So they've been doing some work on the e-bikes. What else did they do? Electrolysis, based energy claims, private client, development high pulse power radiator for Tesla, gravitational effects. So it seems to be a lot of their stuff is based either on energy devices and gravity devices. That's what a lot of the stuff they've been working on. High voltage power supplies for international safe fire solar plasma experiments. Yeah, so yeah, that's a bit of his website there. So very intriguing. I definitely want to get my device tested. That's for sure. Hopefully Gerald will join us. I don't know if he's busy tonight or whatever. I sent an invite to him. Bernie says he's going to join us. I don't know. We'll see what happens with that. Mike, you seen the video I posted this week on the Renegade?
I saw you got a new wheel
Mm.
printed out. Maybe
Yeah,
you changed something
yeah.
to
I
the wheel.
reprinted the whole thing. Um, Actually, maybe I can bring it out. Just bear with me for a sec. I'll be right back. I'm trying to juggle all this stuff around here. Running the show, juggling my experiment. Got everything going on. I gotta change my camera here for a sec. Just bear with me. Camera. So here's the new setup. So I re-engineered this whole compartment. So before I was gluing everything down. So now I've got rid of the damn glue. The glue was driving me nuts, for starters. So I made the compartment so it's all one piece. I could actually take the 4 screws off. The whole wheel assembly comes off in one piece. So that's really cool because you know, it's easier. Like the thing spins 10 times better now. It's
You
all in alignment. I I I
you have
went
four
into
mags on there, right?
what's that?
There's 4 mags on there?
Yeah, always
Ma
4. Always 4 pulses per revolution. The maximum wheel
uh
size for these motors should not exceed 5.5 inches. If you go bigger than that, you're not going to get the speed you want out of the motor and the proper pulse width. So that's a couple of little tips if you're building these motors. You go over 5.5 inch diameter, it's too big. I'm finding that I get way
Trigger's too long.
better. I'm getting way better performance with the smaller wheel than the big wheel. The big wheels are too big. Eventually, they become too heavy. It posts more of a drag on the system. Um,
What, on your bearings? Only your bearings, really.
well, okay. Uh, Mag Mag M4 is saying, "Can you add more magnets?" No, no, you can't. If anything, you go less. 4 pulses per revolution. If you're using the spark gap switch, that's the only way it will work with the spark gap switch. There it is. There. Okay. So, in order for this thing to fire correctly and with the right amount of duty cycle versus pulses per revolution, maximum 4 magnets. I did it with 6 before. I get better performance. Even Robert Adams, if you look at his old patents, he actually talks about this. He says, you never go over 6 magnets, always under, right?
You get
Because,
more torque. The more magnets you have, you get more torques.
yeah, but what it does is screw up your pulse width and your duty
Right,
cycle,
right. 'Cause they're
right?
so close
You're
together to
trying,
keep
you're
it.
trying, yeah, that's right. So you want this thing to actually physically have a separation. There has to be a zero time of
A
current
nice
flow.
an off cycle.
Yeah, it has to be an off cycle. If it's too close together, what will happen is the battery will continue to pull and actually will cause an arc to go off inside the spark gap. It will actually fuse itself. It's happened to me before. So if you're building the motor, 3 magnets is all right. 4 magnets is okay. Um, 5 is kind of a weird number to work with. I've done it with 6. It still works, but I find my best performance is always been 4 magnets. Yeah, so
You ever
yeah,
tried making that solid state?
you can,
It's the
um,
same circuit?
but it would have to be the same circuit. The only it really is a solid state circuit. The only difference is what's causing the triggering is the wheel. That's all the wheel is a timing device, nothing more. It's just a mechanical timing device where I'm actually using a mechanical switch. I'm also using a mechanical timing device. That's all the purpose of the wheel, what the wheel does. But there is a little bit of a reaction that goes on when the magnet of the wheel passes through the coil. There is a reaction there. So there is a purpose for the wheel. I have tried to build a solid state device a long time ago. I wasn't really getting the results I liked. The second I put the
I'd say
wheel
if
into
anything,
it,
the purpose of the magnet is to create that specific type of
a
trigger,
snap.
that
It's a
switching,
snap. It's a
right, the
snapping
switching,
effect. Yeah, I
right.
call it
But
a snap.
you could still do that with a magnetic field from an electromagnet per se.
Yeah,
You can
yeah,
still create that snap,
yeah, exactly,
push pull,
for sure.
um, with an
So I'm
electromagnet.
so I'm still not done with this. I'm actually going to make it a 2 level. So the bottom level is going to be coming this week, and where I'll be able to put all the electronic stuff on the bottom, and then the motor will sit on top. So I got a couple ideas. I had one, I tried it, and it was a complete utter failure. So I didn't like how it turned out. So I scrapped that idea. going to plan B. So this will be a two-stager, and this will be the device I will take to Hathaway Research. I want to show him the small model first, and I'll tell him I'm actually working on a bigger one, and hopefully this will interest him enough that he will invite me back. Hopefully I can get in the front door in the first place. Hopefully that I can actually have that happen. So we'll see. We'll see what happens. See if he invites me.
He takes in validation projects.
What's that?
He takes in validation people.
Oh yeah, well that's what he says. Any private inventor or whatever has a device.
Okay.
Yeah, he says it right on the front page of the website.
So I can send him my stuff too.
Anybody can. Yeah. And I think he has people all over the world send him stuff. So yeah. Yeah.
He's like a peer review.
Right, exactly. And that's what I need. That's what I need to get done, right? So that would be a good thing. Then I can find out if I'm actually that I'm not crazy, Actually, what I'm doing actually makes some sort of sense. Like even if it's, I'm not like talking about a crazy COP. I'm talking about if I'm actually getting over unity effects, even if it's a 2 or 3, if it's even real. But I think the other thing too that would be kind of intriguing for him is when I tell him the way I fire it, because I'm releasing power from the mass, that my batteries don't die, or they take an extremely long time to die over a long period of time, where normally, so yeah, we'll see what happens. I just want to get this device made and then get a good demonstration, and then since that's done, then I'll definitely try to get a hold of them, right? Who else we got here? Oh, you got some stuff here. You got 2 things you want to show?
You too. Yes? Hey? Quite a good scene, isn't it? One man crazy, 3 very sane spectators. Yes. Yes, the badges.
Yes, I'm going to your rotary sport
I don't know about copyright, so I got to worry about that.
I don't think so. It's black and white.
Got your double throw system here. Maybe you can tell us about that.
Oh, this is see the read up there on the top left. It's a read switch in the top left.
Okay. Yep.
It's just being triggered by the magnetic field from the inductor.
The coil itself. Yeah.
So the switch on the bottom left, power switch.
Okay.
When you turn on the switch and the 2 levers are pointing to the right,
Right.
it energizes the coil and then flips the read, which then energizes the car relay, the double pole, double throw relay. Sorry. It's labeled A, B, C, D. I'm sorry, A, B, and C points to show you how it's wired.
Yeah.
Yeah, it's just the relay is in series with the trigger coil of the relay to ground to the negative of the single battery, the drive battery. There's only one battery in this whole system. It's not only is the batteries, not only is it running the relay and the read, it's also running the electromagnet
Mhm. Yeah,
that's driving
and
the read.
that's basically what Bedini's doing. He added that extra winding inside his
There's
main
isolation
coil.
there, you know,
Yeah.
like you do with the photo resistor, the same kind of thing
Mhm.
is happening here with the isolation. I guess the isolation is with the relay itself. The coil, the inductor that flips the two gates is where you have isolation right there.
Right.
And also the magnetic field from the inductor is isolating the reed switch from the circuit,
Right.
from the flyback part of the circuit anyway.
Yeah.
So I don't see the flyback getting to the reed switch or the
Yeah, I made
relay.
a little oscillator today. Basically, I took a little function generator that you buy on Amazon, and I hooked that function generator up to the SSR. Lo and behold, it works. So I hooked it up to a coil with a light bulb on it and four 9-volt batteries in series. So
Yeah.
I was triggering the coil using the function generator and actually triggering it with the SSR. And it works. And here's the other cool part. If I get the frequency just right, guess what happens? The batteries start
Uh,
charging. It charges itself.
hmm.
It charges itself. The back EMF. If you get the right frequency and duty cycle, you get that right pulse, that back EMF coming off that coil, ricochets right back into the batteries and starts charging the batteries. So I was charging a little 9-volt
I've
battery.
yet to see that. I've seen it with the Bedini setup,
It's so easy.
and
Know
yeah.
how you do it. It's exactly the way I say it. And the thing is, you don't put any diodes in it. You don't put any diodes in it. You let that flyback go back into the battery. So as I'm running the circuit, not only that it's running the light, if you get the right duty cycle, I think one of the best settings I had was 10
Well, I
hertz.
gotta see this circuit where you don't need diodes. That's
You don't need it. I didn't have any diodes whatsoever in the circuit. It is easy. All it is to shut the circuit on and off. I'm using the SSR. So you got the one wire that goes to your battery, comes up the positive goes to your coil, out of your coil into a light, and from the light back to the
the negative of the battery.
SSR, uh, SSR, or the negative
Which
of the battery. Sorry,
what is
correct.
the SSR switching? The which pole of
It's
the battery?
it's switching the positive pole. I
Just the
got it.
positive.
Just the positive. It's just in between that to control it on and off. So
And your
I
light's
set,
negative is connected to the negative of the battery.
yeah, it's a complete loop. It goes all the way around. It's just that the SSR is controlling that current flow on and off, on and off. It's just like having a switch there. I'm using the SSR to do
So what
that.
I'm saying is that when the flyback reverses polarity, how are you going to get it back into the battery in the right direction? Because it's
It,
not
it
wired in that direction. You have
well
to turn the
because
battery around. You'd have to turn the
you
battery around.
you would think that, but it's charging because it's radiant energy. It's cold energy. When it's radiant cold energy, it's not positive and it's not negative. It's a pulse.
So you got the
That
light in series with the switching and the inductor and the
Yep,
battery, all in
everything's in
series.
series, all in series.
No diode.
No diode.
And
It's
it's
charging
going
the
back to
battery.
the battery.
Yep,
'Cause that's a
it goes back.
typical load circuit what you're describing there.
Yeah, it's a typical load circuit. Nothing fancy about it at all.
Only thing is the load is not constant DC. It's switched pulse DC.
Right. So it doesn't make it
Or
positive
the
or
circuit's
negative.
not running constant DC. It's running pulse
It's
DC.
cold. It's cold
That's the
electricity.
only difference here.
Yeah, because technically speaking, if that were the case, it would short itself out and the batteries would start overheating, right? Because you're
Well, as long as
sending
you got the load running, that's not going to happen.
right,
There's a light on there.
right. So it's a balancing act between the frequency and the duty cycle. So one good setting for some reason was 10 hertz at uh, 10, yeah, 10 on the duty cycle. It was 1010. Another one was 34 and 9, 9 on the frequency. It was weird.
Yeah.
It was weird. I could step it up higher in the frequency, and then the duty cycle, I would just bump it up in single increments, and I was still getting the same effect. So, and it wasn't damaging the battery; it was charging it up. I was watching it in real time. So, obviously, that power that's going into it is not parasitic. It's not hurting it. It's not heating the battery up. Nothing. So I had 4 9-volt batteries going in series. So yeah, that was pretty interesting little experiment I did there today. It's simple. Just your whole circuit is in series to make the light run, and then in between, you either could be on the negative side or on the positive side. You put the SSR there, and then you control the SSR with a function generator, the small one, and
Right,
you're off
you're
to
right.
the
You hit
races.
the key frequency and then you're good to
Mhm.
go.
Yeah,
I
yeah,
could agree with that. I just think,
it works. I did it. I was working on it half the morning.
all right, right. In that setup, you need to be at the right frequencies, but
Yeah,
with the diode, you don't need to be in any frequency
right.
at all.
So I set
Any
it so
frequency would work with a diode. Any frequency will work. Really, you know.
what I did was just before it was pulsating, and then just before the light would cut, excuse me, before the light would actually cut out, that's the frequency right there, just before it cuts out. And I just had the
Oh,
voltmeter on it, and yeah, I just had the voltmeter on it, and I'm just watching it oscillate, and then it's creeping up, you know, going higher. It's charging the batteries.
you had
And
a potentiometer on your light or something, or
no,
current
nothing,
limiter, or
nothing at
how did
all.
you? Oh, your source. You turned down the source a little to get it to
No,
that
it was
point with the
full
light.
blown 4 9-volt batteries in series.
How did you get the light to dim down right where you needed it to?
Well, the second you start playing with the frequency, as soon as you hit a certain
Oh, the
frequency,
frequency. Right. Okay.
right? As soon as you hit the right frequency, the light pops on.
You didn't change your voltage. You just changed the function generator or
Just the
frequency.
function generator. I control everything with the function generator. Yeah,
Those things are cool, huh?
I love them. They're neat little devices, but they're kind of they're touchy, and you got to be careful with them. I run mine with a 9-volt battery,
It's basically what an
and
Adreno is.
yeah, yeah, just a simple version of it. I got one on Amazon. It's just a cheap ones for $20, but they work. So
They have the one called a Lego Uno. It's half the price of an Adreno. It works just as good with Adreno code. I've
oh,
tested
okay,
it.
yeah. I got this just cheap one. I can show you. Hold on a sec.
I like that double pole.
Yeah,
I like
it's
that
just one
double
of these
pole.
guys. Just a cheap
Oh,
one.
that's it. That's a function generator.
Yep, yep.
God, jeez.
Yeah,
Things do get smaller, huh?
it's a cheap ass thing, but it works.
Yeah.
Actually,
It's
if
a
you give
lot
me,
easier to control it than to with an Adreno needing code and all that. You just push the button.
yeah,
Right.
yeah, this one's push button, so one side's frequency and the other one's duty cycle. It's pretty easy. I just hooked up a 9-volt battery to it. Hooked that up to my circuit. It runs my SSR perfectly, no problem. And yeah, you can do some neat little experiments with that.
So I like that double pole, double throw relay circuit that I just posted on my channel
Yeah,
because
it's kind of neat.
I think it's better than the other one with the 2 batteries. This one's just 1 battery, and it's still bouncing back into the single battery. You could put, 2 batteries in parallel, but it's a lot simpler to build and
Yeah.
even less parts. It's 1 coil instead of 2, and 1 battery instead of 2.
Just check something. Yeah,
The
we
other
got.
circuit I had was 2 batteries and 2 coils, which also works. But I'm thinking it's like, what's the point
Mhm.
of having an extra battery and an extra coil when you can do the same thing with 1 battery and
Yeah.
one coil? And that's why I decided to go online, look up a double pole, double throw relay circuit, and I just threw it into Photoshop and
Oh,
made that video.
be- before I forget, I want to make a program notice here. Uh, Easter lands on the 31st of March this year. So Good Friday is the 29th. I'm not going to be doing a show that Friday. So we got this today, and then we got next Friday. And then the week after that is the 29th. That's Good Friday. So what I'm going to do is that night we won't do a show that night. So because of the Easter holiday, and also the same week. My birthday is the same week, so it's going to be a kind of a busy week family wise. So my birthday is on March 25th. That's coming up.
How old are you, Mike?
51.
50. Oh, you're older than me.
Yeah, I was born in
I'll be
73.
50 this year.
Yeah, I'll be 51 on the 25th.
Half a century.
Don't remind me. My wife bugs me all the time because my wife's like 8 years younger than me.
Yeah.
She just her birthday was on March 2nd. She just turned 43. So yeah, I get a little bit of a head start on her. But yeah, time goes.
Unfortunately, you need diodes here because it won't work without
Yeah,
the diodes.
yeah. That's the only way you can funnel that power through the circuit to get where it needs to go and not fly back in a spot where that power actually could get wasted, right?
Well,
Makes
I mean, it's
sense.
flying back into the battery. That's the same battery that's charging the coil.
Yeah, but you're
I
directing
might
it
just I
through.
might just abandon the other idea with the 2 batteries and 2 coils and just go with this. Because this
Well, it's
is way
refining a
easier.
design, right? Sometimes you can work on the same design for years and always make some kind of an improvement down the road.
Well, I say that because you see the one inductor here. You
Yeah,
could just, using this way of triggering, energizing a coil to run a wheel, a pulse motor, you can take that one inductor, split it in series into 4 inductors in series,
yeah,
and place it around 4 magnets around one wheel,
right.
and you're done. Where's the complicated wiring here? You don't need to buy any transistors,
Yeah,
and with one relay, you can get 2 pulses per um, two. With one relay, you get 2 pulses
yeah.
per half a cycle for 180 degrees.
Sending
Four
Gerald
pulses,
another
4 magnets,
invite.
it goes.
I was hoping Gerald would come on tonight. He said he was coming on tonight, wasn't he? Hopefully. I sent
I
him
don't know.
another invite just in case. I don't know, maybe something happened with his gear. Yeah, Mike, just go on with this here for a minute. I'm gonna zip out for a quick smoke and come right back. So you can kind of maybe just go over everybody. Don't forget live chat's open, everybody. So if you have questions for Mike and his circuit, please ask him now. Be a good time. I'm just gonna go for a quick smoke here. I'll be right back.
It's just a double pole, double throw relay. That's a double pole, double throw relay. It's a standard relay you can buy. It switches positive and the negative. And it will energize that coil up the top there, and you know, in two different polarities. You'll flip the plus and minus around between each switching event. You see the two arms are in the middle right now, and then they're to the left, and they're back to the middle and to the right. When these arms are in center point, the circuit's flying back. There's no power energizing the coil from the battery. It's just a flyback moment. But when the arms are to the right or the left, making contact to the coil, at that point the battery's energizing the coil. And when the arms disconnect from those points, the coil flies back through the diodes into the same battery that charged the coil. The arrows are there to help guide. The red arrows are the battery power, the battery energy coming out of the battery into the coil. The green arrow is the flyback event from the coil in the reverse polarity. Yeah. Yeah, I try to narrow down the components to the minimum. And the choice to go with a double pole, double throw relay was part of that, you know, minimal parts type of circuit. Again, the red arrows is the forward energy charging the coil from the battery. The green arrows is the reverse flyback event going back into the battery.
Okay, I'm back. I am back. All right. Still there, Mikey?
Yes, sir.
All right. There was another actually YouTube channel that I was looking at this week. Let's see if I can find it. Here we go.
So far, I've eaten nothing but meat today and water. Don't feel that bad.
Okay, here, I'm gonna share my screen again. There's one guy here I want everybody to check out. Share screen. Okay. All right. This guy here, from what I understand, he has passed away. Dr. Stifler. I don't know if you've seen him. His channel is still up. He does some really good experiments on static field modulation. I think a lot of people should actually go and try to check out some of his stuff. Yeah, he does a lot of like Tesla coil stuff. Yeah, he also let's see his videos here. How many videos he actually has posted? He's got some really good stuff, like a lot of radiant energy stuff, double loop, sine wave experiments. They look pretty simple, but the theory part is really neat. That would really help people if they're doing radiant energy experiments. But I believe he's passed away from what I've heard. He's no longer with us. He was a pretty old fella. He must have been in his 80s for sure. But he's got a quantum energy receiver. What else does he have? He does a lot of like Tesla radiant, Slayer exciters, water cooling exciters. That's weird. He does some electrolysis stuff, gas measurements. Yeah, he's done quite a bit of electrolysis stuff by the looks of it. Yeah, he's got a pretty good YouTube channel. It's too bad he's no longer with us. And he's old school. You could tell from his experiments what he was doing. He's pretty old school. And he made quite a few videos, which is great. Hopefully they stay up. A new diode electrolysis design. That's kind of neat. And he's only using a 12-volt battery. And he's using a Tesla coil. That's neat. Yeah, I'm definitely going to be going over his site this week. Does a lot of flyback stuff, flyback experiments. What else we got here? Yeah, he's got some neat stuff here. There's a couple of guys out there that really talk about this guy a lot. So I finally found his YouTube channel. And yeah, that's it right there. That's all his videos. Videos did he actually post? 163 videos. Now let's see if his website is up. No, his website's now gone. That sucks. Yeah, it's too bad. Light receiver assembly. Yeah. Stuff like that, it's pretty cool. Let's see. Mike, have you tried fresh bucket of water connected to my unit?
You gotta bring up the circuit to the Renegade.
That could be dangerous.
What?
Put water near my device. That could be.
Why is it dangerous? Is DC?
Well, First of all, how the heck would I get water near the device? Like in the way that I could actually like get it reacting with it.
Use the water as part of the circuit. 2 probes. You know, the open loop, the one
Yeah,
wire circuit.
make it yeah, actually part of the actual circuit. I guess
To
you could
ground.
do it.
Before ground, put the tank of water. Two probes, then the ground.
You probably could do it. I seen this guy that runs a plasma channel. He did the circuit once using water in tubes, like just flexible tubing that you buy from Canadian Tire or your local hardware, and you fill it up with water and you put 2 screws on the end of it. So instead of using wires in a circuit, he used actually the induction of the or the continuity of the water, right?
Right, it's just yeah. If you're pulsing a circuit, that pulse will go through the water.
For sure. But what would the resistance of the water be? I guess you would have to test.
Add some salt.
Yeah, salt water would do it too. Yeah, that would increase its.
Sodium, any electrolyte. But
Yeah.
that's only when you want to pass current through the water. What if you don't? What if you don't want to? Maybe you just want to use it as a frequency transmitter, not so much current, but frequency or
Yeah.
signal.
That'd be interesting. Definitely.
I mean, because
Like
they measure seismic stuff in the earth, right, with just a coil and buried in the ground.
Yeah. Exactly. You're making me hungry, Mike. Yeah, watch it eat
I do
chips or
that.
whatever. You're making me hungry now. Yeah. Get myself a little snack here too.
It's nice to be able to run experiments when you got like a warehouse where you can just
Well, I
make a
don't have
mess.
a real. See, that's the thing. I don't have a real lab, right? That really
Most of
sucks.
us don't, believe it or not.
Yeah, like either doing it on my kitchen table or what. But I would die to have my own lab. I could put all my meters out and everything, my signal and function generators. I could have it all set up.
Those who have labs don't make much stuff on paper. They're busy making stuff in reality, and it never
Yeah.
gets to the paper because their lab becomes a jungle of different experiments.
Yeah. Oh yeah, for sure. We get.
It's like a Pandora's box. So, you start one experiment, next thing you know, you got 100 experiments you want to do.
Exactly. Get in over your head. Gotta top up my coffee here. It's the only thing I drink coffee while I'm doing a podcast. Always gotta have my coffee going during a podcast.
Coffee.
Can't.
So try putting Ben. I hear some people put benfotiamine in their coffee.
What the heck is that?
It's vitamin fast soluble form of B1.
And what does it do for you?
Well, it's your #1 source of energy, and it does a lot of stuff. What else? Glycation. It prevents sugars from oxidizing.
Yeah.
That's important. So we all get thiamine deficient because we eat a lot of carbs and sugars, and you need thiamine to break down carbs and sugars. So, being on a Western diet, you're going to run down your thiamine as you get older. You have trouble breaking down carbs and sugars now.
If I'm feeling good, I don't lack energy. That's for sure. I know when I feel good. So I've been taking a bunch of stuff in the last little while because I was sick there with bronchitis. That really kind of took me for a loop.
Thing about the thiamine though is like they say, there's no way you can't overdose on it, by the way. But the pills are like 300 milligrams, but you don't, in clinical studies, they didn't find any results in in patients with illnesses on that dose until they reached about 1,500 milligrams.
Right.
Then they noticed the patients were improving from
Right.
whatever their illness was.
Well, one thing I have been taking the last little while is omega-3.
That's garbage. I made that mistake. I've made all the mistakes that you'll probably make in the health arena. Stay away from vitamin D. I'm warning you now. I made that mistake too.
Well,
I was
how
mega
about,
dosing it. It's
well,
poison, dude.
but I heard
It's an alcohol. It's an alcohol. It's cholecalciferol. OL. It's an alcohol. It breaks down to an alcohol. It's a plant product.
so
It's not.
what the omega-3 you're talking about, or vitamin D?
Cholecalciferol is not what your body makes as far as a hormone that we call D hormone. Your body does not make cholecalciferol.
Mhm.
That's a synthetic form of vitamin D or whatever. It's bullshit. It's just bullshit. All these things out there in the health world, like choline, for instance. Choline, take it. It's healthy. I made that mistake too. Choline will escort and shove all the retinol in your liver, and meanwhile your liver's trying to get the retinol out. You're taking choline. So if you eat eggs are high in choline, and they're high in retinol. So the choline will escort the retinol to your liver, and you'll get vitamin A toxic like that over the years. Toxic with retinol, which by the way is also an alcohol. Retinol, OL, alcohol, OL. Retinol breaks down to an aldehyde before it breaks down to an alcohol.
Right.
And neither one of those are good for you. Neither the aldehyde or the alcohol. So you have to eat foods that are low. You have to eat foods that are low in aldehyde forming substances or alcohol forming substances. And that is plants. When you want to make alcohol, you use a plant.
Yeah.
You can't make alcohol out of a dead cow's ass. You have to use plant matter. So your liver is like, trying to get rid of this, aldehyde forming plant matter food that you've been eating all these years from plants, bread, cheese, high in retinol, dairy. Casein is encased in retinol. Retinol is encased in casein. Sorry. And what retinol breaks down to an aldehyde known as retinaldehyde. So your liver has a pathway called ALDH, aldehyde dehydrogenase. It breaks down aldehydes. But but you can only stand so much over the years. You gotta limit.
Limit your intake. Yeah. Because it's impossible to eliminate all this stuff out of your diet. It's like
It's addictive. The plants are addictive.
Yeah.
It's not impossible. I've done it with meat a few times. I went 5 days with nothing but meat and water. Nothing else. I was fine. I felt awesome. I was like, I wanted to do 100 push-ups.
Yeah.
I never felt like that. As soon as I broke down with my addiction and had a piece of bread or whatever, there it goes. I don't want to do those push-ups anymore. Because the bread is full of phytates, which blocks your zinc, and the zinc is your body's using the zinc to get out the aldehydes.
Right.
It gets the toxins out. The zinc does. It gets a lot of toxins out. Zinc gets a lot of toxins out. It's a lot. Cadmium, lead, you name it. Copper, retinol.
How about magnesium?
Yeah, that's good too. But when you want to really clean up your liver, you need zinc, and you need B1.
Right.
Because ATP, it's just a lot to go into, but
yeah,
B1 is a big one.
Let's get back into the energy stuff. That's what.
That's the whole thing. B1 is for energy, for your body's energy. The problem is the water soluble form of thiamine. You don't get much out of it. You don't absorb much of it. So you need the fat soluble form.
Right. Yeah, so this week I'm gonna be working on the Renegade to get it finished, and then I need to perfect the overall design of the output circuit, right? How I'm gonna do it. Managed to recover some old it was off an old power supply, some old 200 volt capacitors or 100 microfarad. So that was cool. I was able to recover those. Actually, let me get them. I can show you. Got it here. Oops. Get caught on everything. So I was able to recover these. I got two of them. They're 200 volts at 470 microfarad. So I got two of those. I'm going to try those in my circuit this week. I'll be doing some more testing with that. Yeah, so it's a lot of experimentation this week. I want to finish the build. I'll be doing a video on that. Hopefully Bernie can join us for a little bit. These shows have been weird times of the day. Joe Layden's.
So you know that heavy feeling you get on your right side? That's your liver, right?
Yeah.
And I've been having that, for about 5 or 10 years.
Yeah.
And I just started benfotiamine. Huh?
I have fatty liver.
Yeah, most of us do, Mike. I just started benfotiamine, 1,500 milligrams a day about 5 days ago.
Yeah.
And I can feel that weight lifting.
Yeah.
Because what happens is, okay, so the thiamine, you need it to break down sugars. And what do you think causes fatty liver? Sugars.
Yeah.
You don't have enough thiamine to break down sugars that you're eating. So you get a fatty liver. And that's why thiamine gives you all the energy, your ATP, because it breaks down the sugars or the carbs or whatever. So your body makes glycine, which converts to glucose, and then the thiamine will probably break down the glucose for energy. Nonetheless, you're going to use up thiamine whether you eat carbs and sugars or not. You're going to use it up by eating meat, because meat has glycine in it, which turns to glucose.
Yeah. So here's a guy that everybody should watch. He's got some really.
He's cool. I watch him.
Joe Layden's. Yeah, Layden's. He's a fellow Canadian. I think he lives in Toronto.
What's up, Joel?
I've been trying to get a hold of him. He won't respond. I want him to come on the show, but I'm going to promote him anyways because I like his stuff.
He's busy with the dumbbells. Yeah, he does a lot of theoretical work. And then he puts it into practice, some of it, It's like us, a cubicle for a lab.
Yeah, so I want to show this one video he has. I'm going to put this up on the screen here. This is similar to what I was doing.
A lot of what he says makes sense, He's working on some kind of a crystal cell lattice right now. series cell or something. Series
People were
coil.
asking me about details of my big coil, my the famous big coil Houdini projects I had about a year ago. So while taking it out to inspect it, I came up with a new design for it that works very well, and I'll explain it. So first, the coil here, people were still asking about it. This is just a spool of telephone cable that I found at the, it was Value Village, and there was about, this was a 200 foot, and there was about 50 feet of it that was already used. So give or take about 150 feet here of turns. And all I did here was I twisted all of the wire. They're twisted inside here. It's 4 wires. And I just twisted them all together to make one big wire. The impedance is 0.9 ohms. So what seems to be very important in these projects here for the inductive kickback is to have the lowest impedance and the biggest mass, big, heavy, like 20 pounds or more, transformers, heavy mass. So anyways, that's the coil, nothing special there. So I was looking at the Bedini projects, and in my earlier projects, I was using cap dumps, and I'm using 1 UF, I'm using 22 UF, and I'm really happy when a 22 UF from the inductive kickback gives me like 3 dumps a second. As good as it is, it's still pretty little current. And as soon as I tried to put big capacitors, I wasn't getting the rate. And I'm looking at the Bedini devices, and he's got really huge capacitors, and I'm trying to figure out why does he have all those big input and output capacitors. So it got me thinking here. So after I tested this, it worked well, so I decided to make a real version of it here, and then I'm actually using, because it works so well, I'm going to show you folks this. So a little different here. Here's the pulse generator, which is a switch which controls a transistor with sharp spikes here that I can control with the pulse generator. But what I'm doing now is, instead of just pulsing the raw power, I'm first charging a big capacitor here. This is a 20,000 UF 40 volts DC capacitor. And what I have here, which seems weird, is a power bar here with 2 power supplies. I'll explain this. And in some earlier videos, I think it was Tachyon Catcher, I was having problems with isolating the input and the controller and the dump and all of that. And I was getting interference, and one module only needed a little bit of current, and the other thing needed higher power for the back EMF dump. And I just would semiconductors and voltage regulators and all that, either I would blow them up, or they'd be out of rating, or I'd be using too much current. And I believe it was Tachyon Catcher, I'm sorry if it's wrong, but I think it was him, that said, stick with magnetics. Tesla had magnetics back in the day. So to limit current, to control voltage and all that, he used magnetics. So that got me thinking. He said, you know what? That's what I'm going to do here. So one little tiny power supply, traditional, no switching, just a real transformer here. And this is AC to DC, and this one here is just a 12 volt, 200 milliamp to control the controller here, which only uses about 30 MAs. So this is very little power and goes in line with what I'm trying to do to keep the input very, very low. And here's a second DC power supply here, AC to DC, traditional non-switching, which is what we want. We want to use just magnetics, and this isolates the two, no problem, easy, simple. This eliminates a lot of circuitry and parts, and it gives us really good efficiency. And of course, this one here is higher power. I realized that instead of pulsing 12 volts, if you bring that voltage, the pure potential higher, you get much more inductive kickback. So I tried first with the power supply direct, and it was pretty good. And this is why I had the idea, you know what, I'll use this to charge the big capacitor and then pulse the capacitor through the switch into the coil. So what we're doing here is we're pulsing the cap. So we're actually charging the big cap. We're dumping it. It's a cap dump in essence, but we're dumping the cap into the coil here. And that's giving us a greater back EMF kickback, which charges the battery really, really nicely. And this is why I want to keep this, because in all of the projects I've done, I think this one here is the most efficient, uses less current, and really has a kick. And to explain here what happens, I'll try and explain it. So a battery, like even a larger one, like a car battery with a higher current rating, it typically delivers its power more steadily and over a longer duration. So the batteries are designed for sustained energy delivery rather than rapid discharges. So even if the battery can provide high current, like I thought of, instead of using the capacitor, use a couple car batteries, but maybe not because of this. Even if it's high current, what I'm getting at is the internal resistance and chemical properties and everything else will limit the rate at which it can deliver, the current in a sudden spike. Now, capacitors, on the other hand, the capacitor basically stores its charge in the electric field rather than chemical reactions like the batteries do. So when they're discharged, you know what I'm saying, they can release if you let it, its entire stored energy almost instantaneously. That's where we get the amps a second discharge, or the joule. So that results in very high current spike for a very short duration. Exactly what we want to do to trigger the inductive kickback. This really highly amplifies the amplitude outputs of the back and the current. So basically, the strength of the inductive kickback is related to the rate of change of current through the coil, basically. So when the capacitor discharges through the coil, it can create a much faster and larger charge and current than the battery can. So this rapid charge results in a stronger magnetic field being generating and then collapsing, which in turn produces more powerful inductive kickbacks, which charges the battery here. So basically, what I'm getting at is if we're looking to create a strong inductive kickback using a large capacitor like I'm doing here with the help of Bedini, which he was doing as well, charged basically to the same voltage used to trigger it, this will yield a significant back MF spike using traditional battery. So even higher current output. So I tested this, and sure enough, it's working really well. And I've got a magnet on here because I can hear it humming, so it gives me an indication if it's working well here. And people keep asking for circuit diagrams, so I actually made the circuit diagram here. I'll try and get a good view on this so you can see it. So what happens here is our two transformers here. So one of them is the T1 and the T2 transformer, traditional electromagnetics. And we're using the 12-volt low current to run our pulse generator, which is running this NPN transistor MJL21194G over here and here. And this switches the capacitor here through our big coil here, and here's our reverse diode for a charging output. So relatively simple circuit diagram. As you can see, sticking with traditional electromagnetics really simplifies and takes away a lot of headaches and makes this work very nicely. So let's turn it on, right? So I'm going to show you the charge of the battery first here. So 8.30. So I'm going to turn the power bar on here.
When I first started,
Of course, the commercials are on.
So now
You
we're
know,
running,
this whole
but
thing
look
with
at
the
how
cap,
quick
though.
that battery, look how quick that's climbing. This is a dead battery, by the way. Look how quick that's going. And we're using milliamps here, maybe 10 here and 30 here. We're actually using more for the pulse controller, then the power we're using, there's an initial spike, right, to charge the big capacitor. Once it's charged, it's like building up a pressure, and then we're shooting the pressure off of a very tight, small hole, and it's shooting very, very strong, and that's what we're doing into the coil here.
Exactly.
We build up the pressure to the capacitor, and it's this pressure that's giving us the, look at that, 8.66 already, 8.67. And my meter wants to go to sleep. 8.68. I actually got to watch it because at about 9.5, it's going to be overcharged. But see how quick it's happening? Just a few minutes, folks. So the frequency right now is 314 hertz at 6%. I've tried it all, and this seems to be the sweet spot. Below it, it charges slower. If I start raising it, the charge goes down. So it's all about finding the sweet spot to saturate your coil, and you stick with that. And you don't need any more than what you need. And if anybody's wondering about the bias resistor, it's anywhere from 1 to 100K, basically, depending.
One thing I want to make a note is he's using an extremely large coil. And that's what I was talking about before, is energy to mass. And that's where you're getting a huge amount of.
Yeah, I could agree with that.
Right. The same thing what Joseph Newman.
Because you got surface area too, not just mass, but surface area.
Right. Well, the surface area is in the capacitor. So, like he says, like
It's
Joe
also in the
saying,
coil, like inductive reactance.
Yeah. Well, the inductive reactance, but if you have a capacitor with it, some more capacitance.
Capacitive
Actually,
reactance.
Capacitive inductive reactance, right? So
They
you're
react
getting a bigger build of charge, and that capacitor is able to allow that charge to build up to a point where it has to release.
Now that you're talking about this buildup of pressure, let me just say something, let me get something out there. My perspective of this whole thing about timing the cap dump. I think it's totally a great idea, but not necessary, because if you have a capacitor in parallel with the charge battery,
Right.
Whatever the battery is not taking as far as the flyback is concerned, the capacitor will take and will continue to rise in pressure over that battery. Right. And once the capacitor reaches its peak charge voltage,
right,
you want to have a charge controller on that to dump it only for the sake of protecting the capacitor from exploding. But
if you have a path,
but let me finish. But that's not entirely true or necessary, because once the capacitor reaches a higher enough potential over the battery that it's in parallel with, that battery is going to have to cave in and take some of that energy sooner or later. So I don't think the capacitor is going to ever explode or ever get a chance to reach that high of a voltage, because it's in parallel with a regular battery.
Right.
And as it creeps up in potential, the capacitor, it's going to keep dumping whenever the battery says it's okay to. And where's it going to dump? Into the battery.
Right. So what we also have to look at is current flow. Okay, so if you have negative resistance in the capacitor,
that's all controlled by the potential differential of the battery and the capacitor, though.
Right. So what will happen is, whatever power, say you have 12 volts in the battery, you'll match that in the capacitor. Now, if you do this with a very large capacitor with a battery, it's not a good idea. It's basically,
it doesn't really, in my opinion, it doesn't matter if you have a lot of farads or very, very little farads. It's all about the potential of the capacitor.
Yeah, it's a lot safer if you got microfarads. Now, the best part about this too, because you have the path of voltage coming from the battery to the capacitor, but you also have a path for it out. That's why you don't have to worry about the capacitor overcharging itself, because what will happen, it'll have that resistance in the capacitor to a point, where it's going to have to release it. And if you have a pathway out, then it could release that power and also provide, from what I've seen, it actually
Right. Speaking of
increase the current.
pathways, though, we're talking about a pathway for the flyback, right?
Yes. Well, not the
Okay.
just the
Speaking of that,
flyback. Not just the flyback. I'm just talking the power.
the
to
high
power
voltage,
battery.
the
Right.
pathway for the high voltage, right? Well,
Yeah.
speaking of that, a regular 12-volt battery only gives you a pathway as wide as 12 volts.
Right.
So when you have a higher voltage capacitor in parallel with that, now you're increasing your pathway for the flyback, which is a higher voltage. You
Right.
can't expect the battery to capture everything, although it will capture a lot of it.
Well, it absorbs it as much as it can.
It's definitely not capturing over 12 volts or whatever. It's peak rated voltage.
Yeah. Yeah. The most batteries will say level off at about 12.6 volts. And then what will happen, you'll notice when you're charging a battery that it won't go much past that. It will take several hours of charge time to actually to exceed 12.6 volts. And I've seen
I
that
think that's all
time and time
temperature,
again.
though.
Yeah, it could be temperature, but I think what's happening, it takes longer for that energy to fill up the full capacitance of the electrolyte reaction within the battery.
You know, on the one token, Bedini's time dump of the cap is also, you know, in some respects, it could be more effective than just putting a capacitor in parallel with the charge battery. I just think it's also, you know, a good idea to let the capacitor and the battery together working in parallel to balance each other out, you know, with the flyback.
For sure, yes. See,
And they'll do that real time, you know, and that might be even more effective.
See, in regular electrical engineering, the whole point of having the battery and the capacitor together is so if you're pulling a load off the battery, you'll pull the load off the capacitor first,
right?
And then draw power, the differential.
But that's only because the capacitor is more ready than the battery.
That's right. But the thing is,
and it's only ready with the first few joules or whatever.
Well, yeah, it's especially if you're like starting huge DC motors and AC motors, you want to have a capacitor there to take that kick instead of the power source, because that's when you get
instead of your battery.
You either fry your battery or you can blow a fuse or whatever. That capacitor will help take that first load, so it's not like you're pulling like a dead short, right? And I've seen it happen before where, you know, you can do some major damage to electric motors if you pull a straight load with no like gradual buildup. You know what I mean? Where the capacitor will help with that. It will take that first hit. So it's battery protection, right? And a lot of solar homes now are using that. They'll have your stack of batteries, and then you'll have a stack of capacitors right after it that are equal voltage with the battery. And then all the power that's provided for the solar system is going to get pulled from those capacitors first before the battery.
You know, I just think the way people are doing solar is it's great that they're doing it all, but you know, you could cut your panels in half. You know, drive a pulse motor, spin a nice heavy flywheel, and go.
Yeah, or just a regular step-up transformer would do it too, Mike. All you have to do is hook up, say you had a small array of solar panels, so you're creating, say, 200-300 watts, right? Nothing major, because you could go out and buy a 100-watt solar panel now for like $100, you know, $150, right? From Harbor Freight.
Right, but you got to store that energy somewhere, right? And if you have a heavy flywheel, you can store it in there.
But what I'm saying is you can actually increase the efficiency and the potency of a solar panel by just feeding that power directly into a step-up transformer and then pump that into a battery. That means you'll charge your batteries faster.
That's true. That's true. You get more effective charge.
Oh yeah, and Laser Saber did this years ago.
Yeah, I know Laser Saber. I've been watching his channel for.
Yeah, he did this years ago. So he's got a say 100-watt solar panel, and it's actually performing like a 300-watt solar panel.
So wait, he's pumping like 48 volts into a 12-volt battery?
Well, no, what he's doing is taking 100 watts, whatchamacallit, solar panel and patching it right into a jewel ringer circuit, like a
Oh,
step
yeah,
up.
yeah.
And the
That's
jewel
even
ringer
better.
circuit's charging a whole little bank of
Well, the
super
jewel ringer is just creating flyback, which is
Right,
whatever high voltage that is,
right.
500.
So now that power that he's created now with the jewel ringer circuit far exceeds the amount of input being done by the solar panel. He's actually basically tripled the power output of a solar panel. So
Yeah,
instead
no,
of
jewel ringer
having,
is way more effective than the
yeah,
way of charging.
jewel ringer circuit, or you could call it almost like a Slayer circuit. Almost, they're very similar, very similar. And yeah, he was getting kick-ass power coming out of that little 100-watt panel. And he actually built everything on the backside of that panel.
I just think batteries are a waste of, you know,
Well, they're
toxic
not.
chemicals.
Well, you have to have a storage medium
I
of
mean,
some
when
sort.
you could spin a heavy piece of iron
Well, yeah,
safely
yeah.
in a box
There's different.
outside.
Sure, there's a lot of people are actually. There's one company.
There's no chemicals, nothing. No chemicals. No, you don't need to change any
Yeah,
parts.
flywheel generator system that's using the inertia. They got these silos. I don't know if they're in Switzerland or
Have you heard of the
Germany.
the pipe bearing system? The pipe inside of a pipe?
I've heard of it.
Well, you can make a bearing like that. You just have a pipe that's sized just enough to be small enough to fit inside of another pipe
Right.
that leaves a very small air gap, and then your air becomes the bearing. Once the wheel starts spinning, it pressurizes the air in there, and it just
Yeah.
those bearings last forever. I mean, there's
Right.
two pipes, and you can put a lot of weight on them, a lot of weight.
Yeah.
Yeah.
Yeah, well,
And
there's a couple companies out in Europe that have actually made these silo generators. They're just spinning masses, and whenever there's a
right,
need for a current flow, they
that's
just
the
flip
way to
the
go,
switch.
man. That
Well,
is
yeah,
so.
it's definitely something that people are working on. This technology is out there. They're doing it.
Even for
So,
cars, you could put a spinning piece of mass inside of a car.
well, they're doing it in the F1 cars right now, in the Formula One. They got flywheels inside
Uh,
their engines. Some of them have been
well, that's to run the
experimented.
gearbox, though, right?
Well, no, it's to increase the acceleration of the engine outside of a, like if they go into a big turn, where they slow
Oh,
down
right.
and
It
then
gets
they
balanced, right?
accelerate, right? They go around the turn, they have to gear down, and that flywheel is still spinning at high RPM. All they do is engage the clutch, catches the flywheel, and they freaking slingshot right out of the freaking quarter. So F1 has been working with this stuff. There is actual practical application to this stuff.
Gimbal technology.
Yeah, well, flywheel. It's flywheel technology.
Right. And, if you have like a 300-pound train wheel, iron
Yeah.
train from a train.
Oh, yeah, I know how much energy it takes to stop one of those things spinning at 100 kilometers an hour.
Right. But a pulse motor can, with magnets on iron, can spin it
Oh
up
yeah,
slowly
the
over
most
time
energy,
with one
the
solar
most
panel.
the most energy consumption would be on the startup. As soon as you get it spinning up to high speed, it takes very little energy to sustain that wheel turning. And then, all you have to do is just pump a little bit of power into it just to keep it running. And you could get quite a bit of performance out of a high load spinning mass, right?
Right. Once you get a three-phase stator on that same spinning wheel with another set of magnets on the face of it,
Is that your friend
and
Lulu? Is Lulu joined us?
that's Lulu.
Lulu wants to join the show. You can join the show.
I'm just saying, if I were to do a solar system, I would just get one panel, a pulse motor, and a heavy flywheel. And that same flywheel will be driven on the perimeter. The circumference will be driven that way,
Yeah.
with magnets on the circumference. And then another set of three-phase magnets on the faces of the same rotor. And you have
Yeah.
stators on both sides. And you're putting out AC real time.
Yep.
whenever you need it. You don't need to store energy in anything. It's already stored in the wheel. Spinning.
Lulu, the invite is on the live chat there. If you want to join the StreamYard with us, feel free to join us. I'd like to have you on. I liked when you were on the last time. That'd be great. Yeah, flywheel technology's out there, right? It's people are using it. F1's using it. A couple companies in Europe are
It's like
making power
1/10 the
plants.
cost of solar,
Yep, for sure. You
and
just
it's 100 times better.
and if you need amps, man, can those things really pump current if you need it? You put the load on that generator that's hooked
It's
up to
basically
it.
the same setup as the Niagara Falls generator plant or whatever.
Well, it's
That's what-
using water. You got the water, constant water flow, right? So, okay, Lulu is
Yeah,
here.
the water was pushing those heavy flywheels, and those flywheels were storing the energy,
Right.
and then that was generating your AC with the stators.
Lulu's here. Good evening.
Good evening.
How
And
are you?
Hi, everyone. How are you guys?
Excellent, excellent. Yeah, glad you were able to join us last time we did the live stream there. Like your insight on stuff.
I think you guys were talking last time about you were asking me the levels. Doesn't it make a difference in the voltage? The output voltage. I never answered your question, but I would assume it would. The higher you
Higher
go.
potential, yeah. That's
Yeah.
why Tesla always worked in the hundreds of thousands, if not millions of volts.
Okay, so I was right.
High current, or not. Sorry, the current comes later, but high potential, high frequency, and then the way Tesla was able to get a huge amount of power is the step down. When you step down the voltage from say 4 million volts down to say 120 volts, well,
Hmm.
guess what? You also made a massive amount of current increase. When you drop a high voltage down in a step down transformer, your current now goes up. Now, his transformers were known to put out 2,500 amps, which is massive, massive amount. Imagine on the step down how much current that thing would create. Huge amounts of current. So, with my Renegade device, I've always worked with higher potentials. And other guys, Paul Babcock, Jim Murray, all these guys agree. Working with 12 volts is a complete waste of time. You've got to get 25 volts, 48 volts, 100 volts. Work with the higher potentials because when you step down that higher potential, now you're going to gain current. And that's what you need to drive heavy load circuits. So there's a lot of truth behind that. Even with Joseph Newman, his motor weighed 7,000 pounds. He was using 84 9-volt batteries, the small little 9-volt batteries,
Wow.
hooked them up all in series, getting 460 volts at 50 milliamps. Okay, 50 milliamps. And he was moving a 7,000-pound motor.
Wow.
So it's potential to mass. If you got a high potential going into a large mass, guess what? You got a shitload of horsepower right at your fingertips.
And I would
So
love to actually like hands-on build these things, not just like
there
theoretically.
are ladies out there doing it. There was one lady, her name was Janice. She was doing a lot of jewel bringer and jewel thief circuits. There's not many ladies out there. I wish more ladies would get out there. There are a few, but not many. There's obviously a lot more guys out there doing it than girls, but I wish more ladies would get into it, work with the
I
guys
think
too.
most people like get into it for financial reasons. I'm more into this because I'm exploring the idea of creating enough energy for space exploration. So I have a
For sure.
completely different,
Mhm.
view on.
Yeah, for sure. Definitely. That's everybody has their reasons, and most guys that I've seen in the past that always went the money route, all of them are gone. They all disappeared. It's like, they're all striving for the next big thing. Or the
Yeah,
other guys, or there's a lot of inventors that don't want to share their secrets and they want to patent things. Well,
Mike, you see that?
yeah, what's your VR thing there?
Yeah.
see, once you patent
Lulu.
something, you already have somebody already now has your ideas. They could just tweak it a little bit and then take your idea. But when you don't patent it, you keep the rights to yourself, and it's like nobody steals the idea. So I don't like a patent is a double-edged sword. Like it's a good thing that you get credited for in the academic community for your ideas, but at the same time somebody could take it and tweak it a bit and then repatent it, and now it's a completely different idea because they just added maybe an extra bolt in there, or
Yeah, see, but the
something.
thing is, the patent office are all bought for and paid off, even the judges too, and it's all controlled by the military industrial complex. If they see an invention, say like Stanley Myers or Joseph Newman's device, they're stopped. And even Joseph Newman fought him right up to the Supreme Court of the United States and still lost, even though that two engineers proved and actually did basically off the record admissions that they were told behind closed doors not to issue the patent. So the system is rigged. Okay,
Yes,
so the system is rigged against us. So we know what it is. Where back in the past, in the last 30 years that I've been looking at this stuff, that every single one of those guys that wanted to get a patent were all screwed over. So what does that tell you? It's
don't get a
rigged.
patent.
They're,
Don't
don't
get a
even
patent.
bother. Don't even bother. Don't waste your time. Don't waste your money with it.
Yeah, just
Open source
document.
it.
Like just document that you had the idea on
Right.
video or email it to yourself before, so if somebody comes to get your idea, say, you know what, I already had it, I didn't patent it, but it's been documented that I
Right.
invented it first. That way they don't say,
But
oh, their
I
idea.
don't even, this is where the ego comes into play. You know, me with my YouTube channel, I got over 400 videos showing all the stuff I've been working on for the last 8 years. And you know what? My thing is, I want to show the world that it is possible. It's not impossible. Nothing is impossible.
Yeah.
Now, going into it, 15 plus years ago, I went in with a non-biased approach. No perceived, notions that, this stuff it doesn't work. I went in, I wanted to find out if this stuff was real. I do experiment after experiment. I'm starting to finding, hmm, stuff is working, following what other people have done before me. I'm starting to realize the stuff that they're showing me and stuff that I've replicated is actually working. It's actually real. So if you see it in front of your face on your desk or on your in your lab, and you see a device that's working, it kind of helps with the credibility.
Yes.
So if you start seeing things are credible now, you're taking it more seriously. And that's when the rabbit hole starts opening up and you jump in. Right?
Yeah.
Excuse me.
Like I have a friend that invented this device. He works in he's an oil engineer, and he invented a pump that extracts like oil from the ground, but
Right.
like maybe 2 or 3 times better than the ones that are patented. And so
Yeah.
I asked him once, I said, why don't you patent? He's like, for what? So the other companies like, steal my idea, tweak it a little bit. And then he's like, well, if I don't patent it, we still hold, I hold the secret, and, they generate way more oil. And,
The secret. Yeah, it's
yeah,
a big secret.
uh, I don't
I
know
hold the
exactly.
secret.
Yeah, but you know what? There's a lot of inventors out there that would not reveal their secrets. A perfect example would be Floyd's.
That's called FOMO, FOMO, fear of missing out. That's what
Well, that
happens to these inventors.
yeah,
They get the
Floyd,
FOMO.
like Floyd Sweet was a perfect example of this. He would never. John Bedini was working with Floyd Sweet for quite a few years, And John Bedini got so close to getting the final touches on his device to actually go with it. And that's when Floyd kicked him out. He says, "You're done. Bye. I don't want to see you again."
What makes you
And
think? Where do you hear Floyd kick? When you Floyd kick him out? I
oh,
never.
oh yeah, he kicked him out. Oh yeah, I heard an interview with John Bedini. He said, "I got so close to it." He said, "Bye. I don't want you around anymore." Yeah, he
Close to
kicked him
what?
out. Close to figuring out how his VTA worked. And same with Tom Bearden too. He kicked him out too. Yeah, that's how much fear he was. That's no, but that's the old school mentality. That's the way these old guys work. They hold their pat. They will die with
Man,
their
that's terrible.
secrets. Same with T. Henry Morey. Same deal. He was the same way.
Do you
Same
know,
with
like
Well, no, wait.
the
Well, hold on. They both released, diagrams of their stuff. They didn't hold
yeah,
on to their
Morey
secrets.
didn't release everything. No, he didn't.
they will
No, no,
always leave
no.
something out.
Yeah, T.
Always.
Henry Morey wouldn't release everything. No, no.
You know,
There were
like
certain
a great example of this is like the Voyager 1. It stopped working about like a month ago. Well, all the people
right.
that were working on this project have either died or retired because it's been like 40-year project.
Yeah, it
And the
launched
new
in
engineers, they're having,
1977.
yeah, they're having a hell of a time, or I don't like using the word hell, but a heck of a time, on trying to figure out the algorithm to communicate or to, troubleshoot this, probe, because the older people never taught the younger ones, everything. And
Yeah,
so,
trade secrets.
yeah,
Yeah,
but this is something that's not is not okay not to teach, the younger generation because it's like a
right.
human
That's
project.
the
It's not-
that's the
Yeah,
old school
yeah,
mentality.
yeah.
It's a sad reality, but that's what it is.
Yeah, and something that was spent like I don't know, worth in billions of dollars in information, is that nobody knows how to fix this, and they're working on it day and night for the past month. And somebody said like recently that they're gonna try to, see if they can get it to work up again, but
Yeah.
try. It's not.
I'm just
Not
gonna scoot. I'm just gonna scoot up for a quick cigarette. You and Mike talk. I'll be right back.
sure. Hi, Mike.
Hey, Lulu.
How are you? I love the music that you put on. Sometimes I just put it on and I just listen.
I get it off of Pixabay. It's free, royalty free.
And yeah, I know.
Good stuff. They're making
Yeah.
some good music over there. You see this wheel here?
Huh?
You see the drawing?
I don't see a drawing. I just see a blue screen.
Oh, you got the phone.
Do I need to be on a laptop?
No, I think it's a StreamYard glitch, maybe. Anyway, there's a thing called Ohm's law, V over I times R.
Yeah, I saw it
So
earlier.
when
Whatever you had.
right, so when voltage goes up, current and resistance goes down, and when voltage goes down, current and resistance goes up. Just
Makes
keep that
sense.
in mind.
Voltage goes up, current goes down. Current and resistance go
So,
down.
so
Voltage
does
goes up.
resistance. Current and
So
resistance go down together.
current. Okay.
And when voltage goes down, current and resistance goes up together.
One day I'm gonna be applying for NASA or SpaceX, and when I become an astronaut, yeah, you guys are gonna be on my team. I'm like, okay, there's only a few people I trust when it comes to this kind of stuff, and and Mike is one of them.
That's what Mike was talking about with the high voltage. When you
Yeah,
bring the voltage down, the current goes up.
yeah, faster.
So, yeah, so he brings the voltage up first with radiant spikes, That's how you get your high voltage. Those are high voltage spikes. And then when you're bringing the voltage back down, the current is going up as it goes down. As the voltage is being dropped, the current's going up. So when you take that high voltage through a step-down transformer, you put the high voltage into a coil with a lot of turns, wrapped around a piece of iron that's got another coil with fewer turns, and that steps down the voltage on the fewer turn coil. And now
I mean, the
you
whole
have lower
concept is
voltage,
the whole,
but
whole
more
concept
current,
is
more
we want more
amps.
current. That's the objective, right? I mean, like how whatever we do at the end, we want the current to go
Right.
faster. Yeah, I mean,
So it seems like the general consensus is that when you bring the high voltage down, that's when you get the gain of current.
amazing how that works. You just think more voltage is more current, but not really. More voltage, less current.
Well, you bring the voltage up first with switching an inductor on and off. When you turn it off, the inductor creates a high voltage spike, and that's how we get the high voltage. And that high voltage is high, hundreds and hundreds of volts. So you can stop at any level along there, whatever voltage you want to reach to create your high voltage with that system of switching an inductor on and off. And when you turn off the switch, the high voltage spike happens. So then you just capture those high voltage spikes into a capacitor, you bring your voltage up high. And now when you dump the capacitor voltage down, the voltage drops, but the current goes up. It's kind of like a zero loss system, if you ask me. As you're pumping the voltage up, if you do it with low current, there's no loss on the way up to the high voltage. And as you drop the voltage, your current goes up.
It makes
It just
sense. Like you
it's
have to have.
converting.
I mean, it makes sense because, like, to start it up, you would have to pump in a lot, but then once it's going, all you have to do is just give it a little, to keep it going. I mean, it makes sense theoretically.
You're right. That's another way of running the system, keeping the high potential high, and only dropping some of the potential out. That's also a method. But once you have the high voltage, now it's up to you how to drop it and create your high current. Because when you do drop that voltage, you're going to get an increase in current, no matter what. That's just Ohm's law.
Yeah, you
Ohm's
can look
law.
at you can look at voltage as pressure, right? So voltage is creating that high voltage spike pressure, and then now you're stepping it down through a step down transformer, going from a lot of windings to fewer windings. Basically, you're creating a bottleneck. So what will happen is the voltage
A
potential
choke. They
will
call it a
be
choke.
like a choke. Yeah,
A
exactly.
choke coil.
A choke coil. And what happens, the voltage will drop down because you can't get the rate of flow of pressure through a smaller hole, right?
Right.
Or wire. But the current will increase. And that's the great part. That's why Tesla worked with such high voltages, because he knew the second he stepped it down, lots of power and the current to go with it.
Nice.
But Mike, is it the same amount of power as on the way up? Pumping up the voltage? Is it equal
It
to
takes
the
less.
power
It's
on the way
easier to
down?
create. It's easier to create potential than it does current. So
Right.
perfect example would be Joseph Newman. He used tiny little 9-volt batteries, 84 of them all in series to get the
And
voltage up real high.
they were all dead batteries too.
They were all dead batteries. Yeah.
They just had like 1 volt or half a volt, or
Yeah.
they didn't
exactly.
all have 9 volts. They all had like different volt ratings, 0.02 volts. Some of them were like
Right.
0.5 volts and 3 volts,
So yeah, it goes back to his theory too. So
But
when
when
you
you put
hit
them all in
hot,
series, you get that voltage is now built up to a higher voltage.
yeah. See, that's what
Even though
Joseph
they're all
Newman
dead batteries, they still have this potential behind them.
potential. That's right. And when you got a high potential hitting a huge mass, it's potential to mass. That's the key. That's where all that potential is now basically saturated that large mass coil. That's where the magic happens. As soon as you shut it off, you get a high voltage spike again, which will far exceed the amount of voltage you put in it. And then, even better, if you take that power and now step it down, holy cow, you're talking kilowatts, maybe even megawatts of power. So,
Wow. And this is just
yeah,
with 84 batteries.
84 9-volt batteries.
Okay, and a 9-volt battery is like smaller than the car's battery, right?
Yeah. Here, I'll
Okay.
show you.
Because you're tapping into the heavy side component when you.
Just little 9-volt batteries like this.
Oh,
84.
those. Oh, wow. That's
That,
really cool.
and his rotor was 7,000 pounds.
You know how many batteries I have like that laying around? Like tons. I
Yeah.
was
And you
actually
could
gonna
create, and you put that through an oscillation circuit with a large coil.
even if
You could-
they're dead batteries, there's no
Yeah.
more.
Yeah.
Oh wow, I was gonna go actually take them to Best Buy
We-
and
We
Well,
had a-
actually,
he had a-
running the Newman circuit with those dead batteries,
Yeah.
they charge up. They become conditioned again. I think
Yeah.
they all
Yeah.
balance out. Amongst
Well,
each
you're
other.
you're far exceeding the potential going out than going in.
Because it's like the whole thing. The radiant flyback spike is like it's like 0.0000000000000001 amp,
Right.
which is like nothing.
Right.
But the voltage is like 5, 6, 7, 800 volts.
Right. But when you saturate a very large mass with that voltage, well, guess what happens? All the electrons now start flowing into the system. This is, how it.
Right,
how
because
that-
you're potentializing the system with that high
Mhm.
voltage.
Yeah, it's a trigger. It's what you're doing is triggering the mass. So that's why in my motors, like the small Renegade's 1 pound coil, right? Most people do. Oh, I do 300 turns. I do 2. No, you don't do it that way. Even Tesla, even in his writings, and I found it a couple of times where he states he never goes by turns, he goes by mass. If you go by mass, that's an easier way of calculating stuff. So, like my large Renegade, the coil is 2.2 pounds. I would actually want a 5-pounder, a 10-pound coil.
What's your
Yeah.
resistance on that coil, the 2-pounder?
It's not very much. It's low.
1 ohm?
Yeah, probably somewhere in that range. It's pretty low.
does the shape of the coil matter? Like how
Yeah.
you
Yeah, you could get a bigger back EMF spike. It's based on diameter, not so much the width of it. It's the diameter. The larger diameter, the bigger the collapse.
I have a copper wire, or not wire, like a big old, let me show you what I'm talking.
Spool of wire on a. Yep.
No, not it's like a spool that has, I bought it a while ago, but I never knew what I wanted to do with it. Let me dig that up. It's in here somewhere. It's heavy. Okay, hold on, let me see. Let me show you. Can I? Yeah. All right, you see that? You see that copper?
Perfect.
Yeah.
Oh, it's a magnet wire.
Yep.
Yeah,
Perfect.
it's really
Looks like
heavy.
it.
Yeah, you can do wonders with that. You could create a huge back EMF spike.
That's what, I don't know if there's the writing on it. Let me see. It says something. Here we go.
Let's see what gauge it is. It should say what gauge wire it is. So, 24 gauge or 30
I'm trying to
gauge.
see. Does that mean anything to you guys here? No.
I can't really read it from here.
It just says carbon steel, low alloy, stainless steel, nickel alloy, copper alloy, aluminum, but it doesn't have anything on it.
It doesn't say gauge.
Net weight 33 pounds, size 0.035.
035. That sounds like a 24 gauge.
Yeah,
6
around there.
gauge maybe. That's
Yeah.
good. Now, does it have the coating on it, or is it just bare wire?
I think it's bare wire. Yeah, it's just bare wire.
Oh, it's bare wire. You know what that could be? That could be welding wire.
What is it?
For welding,
Welding.
for a MIG welding.
Okay.
Yeah, you need something that's coated. You
I,
have
I
to
was
have
gonna
a
use it
coating on it.
to wrap it around magnets to see if I can generate.
Yeah, those aren't insulated. They have to have the coating on it, like a red
Mm,
coating.
okay.
If it's bare copper wire, what will happen? It will just short out because it has to be insulated.
Okay.
Yeah, but yeah, if you had something like that that was insulated, that big, oh yeah, you can create huge power with that.
Like
I can.
a 10-foot piece of solid electrical wire gauge 12 is good.
Yeah, something that has coating on it or a plastic coating.
Mm,
Most magnet wire has like a varnish on it.
Well, if you
yeah.
want more mass, you want to get like electrical solid. They have stranded electrical wire and they have solid electrical wire.
Yeah,
It's just like solid
I,
piece
I
of copper instead of a bunch of little pieces of copper. It's one solid piece,
yeah,
and it's hard to it's not that hard to bend, but once you bend it, it holds its shape pretty well.
yeah,
And
yeah.
Good.
Just
I
gotta
just
experiment with it. Yeah,
to make a quick coil out of that
even
with
just
10
grab
turns
that
on it.
wire and even grab that wire and just put like a varnish on it, let it dry, and just try to coat the whole wire, and then you could use it. So it'll take a little while to do it, but fact is you could actually just take that wire and spray it with some varnish on it, let it dry, turn it over, paint the other side, and
That would take forever, though.
it would take a while. Yeah, that's kind
Yeah.
of a long way of doing it.
Yeah. No. I'll just get a new. You know, it would be much
Amazon
easier.
has a electromagnet kit for like $40. They already pre-wound like two coils in there, and it's got a iron core already made.
I don't know. I always
It's
thought
thin,
like the old
it's thin gauge,
sigils,
but
like the ancient sigils, are actually a blueprint of a coil system. So it'd be interesting to look at the old symbols, old sigils, and trying to replicate that into a coil shape of some sort using would be interesting.
Actually, I'll show you the roll that I had. Hold on.
I mean, there has to be something related to
like
that.
the crop circles also have coils in there. All those crop circles, you could see those designs, how they could be, maybe they impart knowledge more than just energy, but knowledge in those crop circles. Like mathematical knowledge.
Exactly. I always thought that there is some equation in those that is a little bit more than just a symbol.
They deciphered one of them out to be a particle accelerator.
I got a couple coils here that I did.
That was affirmative, that
That
one.
was a small one. That was actually, this coil here was one of the first pulse motor
There it
coils
is.
I
Look at
made.
this. Look at this.
Nice.
Hold on. Let me see.
Got this one here too. Got a metal core in it. And I just did my oscillator with this core here today, and I was able to recharge the batteries just from the back EMF. So yeah, you don't have to make them huge. You can still get some results with. Oh yeah, I think I've seen this one before. Yeah, that's on Amazon. Yeah, I've seen that. Yeah.
You saw that? That's a good deal, man. Already pre-wound with the terminals on there.
Yeah.
$10.
Yeah, it's like a Tesla coil. It's got the primary.
You don't
and
got to build
secondary.
nothing.
Yep.
And
much
that
is
coil has that varnish on it,
yeah,
like the
yeah,
stuff.
Yeah,
yeah, that's it, insulated magnet.
and there's a core, iron core in it too that you can take out, in and out.
Oh yeah.
And take it in, put it back out. and
How
Do
much is
experiments
that one?
with or without it.
How much is that one?
It's actually two coils, not just one. Two coils
Yeah,
and an iron core. One,
yeah,
the iron core fits into the smaller coil perfectly, but the bigger coil doesn't come with a iron core. But this kit gives you two coils with one iron core. Yeah, I bought one of these. That's what I did my the experiment with the Adreno with this coil to see. It was a lot easier than making a coil and building a lab. You know?
yeah.
And it's like, there it is.
You know, I always
Uh,
wondered when they turn these things on, would the effect be like in the surrounding? Like, wouldn't that change polarity of things? And you know, okay, when I went to New Jersey to the Falcon Lab, you know, where
Yeah,
guys were, every time they turned on this machine, things would flip around. Like
yeah,
anything that was metal would like flip around. I'm
yeah,
telling you, it was like you know. So I started putting little pieces of metal, like in different places, you know, in the lab. I just wanted to see would they flip, and
yeah,
like it did that all over the lab, and I thought that was like the coolest thing. So whatever energy that they were generating, they
yeah,
were flipping the poles to
yeah,
anything that had
yeah.
polarity.
Since you induce a coil with power and then you shut that power off, the polarities flip very quick. There's
Yeah,
a
but
flip.
don't you think that's kind of cool?
this is
Like,
a nice
yeah,
one.
I
Yeah.
mean, like I don't know with the on a bigger scale effect, were they, were they warping space? Were they warping time? I don't know. I mean, I think
Well,
they were.
they were manipulating the magnetic field in that space and any
Yeah, but how
matter
far
that's
does
in
it
that
go?
space.
Because
It depends
wouldn't that
on its
propagate though?
frequency. Like a Tesla coil, if you have a fairly large one, you could basically fill up an entire room with the flux. And if you have an
Yeah, but
LED, it can
like
hold it up.
magnetic fields don't ever dissipate; they continue. Like
Right.
like they don't just stop to when whatever magnetic field was created. Even when they turn off
Yeah.
the machine, it will still continue. Well,
Yeah.
like so it would have
You know,
a bigger effect than just a local area.
oh yeah, it will
You know.
spread its way out. Like you could fill up a whole house if you have the right oscillator going at the right frequency, like these Slayer circuits that you can make. You can basically transmit an electromagnetic field within meters. Several meters, or an entire house. Like I knew one guy had a Slayer circuit. He could go all the way from his bedroom all the way to the basement and still have power. This wireless transmission of power, what Tesla was working on. So yeah, you can create a substantially large field if you have the right the Tesla coil or Slayer circuit that will create that rate frequency that will travel distance.
Yeah. Science is beautiful.
Yep, it's fascinating. That's what
Just to know how to use it properly. Yeah.
Well, you have to pick a field or an area of the science that you want to do. Like for me, I started off in one area. And then next thing I find out, I'm branching off into these different areas. I'm going, holy, like now I'm starting to see a bigger picture where, like, even my Renegade device, if I'm not feeling good, I just sit in front of that for about 10 minutes and my energy level goes like through the roof. Like, I start feeling better.
No. Wow.
So, like, it'll be like 12 midnight and I'll feel like I just had an 8 hour sleep.
I need me
So,
one of those.
but it's just a pulsing of an electromagnetic field and your body responds to that. So if it's a highly energetic field, which it is, it affects your body in sometimes a very good way. there are
And you
frequencies out there that
you don't have any other health issue, like you don't have health issues or
no,
anything like that.
no,
Oh, okay. Wow.
no.
Okay.
It
Really
could be
good.
just really, really tired. It could be late at night, you're really tired, and then you turn on the device, and within about 15, 20 minutes, it'll feel like you went to bed and had an 8 hour sleep,
How
and
is
now
it?
you're wide awake. And this was something that I was observing over a period of, years, that every time I turned the device on, I was feeling really, really good. But after, working with the device for a couple hours, I'm feeling like physically
How
really
big
good.
is the device?
Tiny, small devices,
You
size
you
of a
know you should
shoebox,
actually
like
take
this.
it
Here's
to
just like
you
this.
should take this device like to, like, let's say a retirement home and turn it on
Yeah,
and see how these people would like,
respond. Yeah,
exactly. And then
like
if you and
this
if
is
it
how.
really, like, they respond well, like they start, like, having more energy, then man, you just invented something fabulous.
Yeah, well, this is nothing new. Tesla was working on this in the early 1900s. It's called electrotherapy, right? Where you're being exposed to a high frequency electromagnetic field and your body's responding to it. So my Renegade device not only creates energy, it also makes me feel better being around it. So
You think
I've
it's
been
making
developing.
ozone?
Um, Depends. If the bigger the spark gap, it will create ozone. Because I fine tuned and tweaked that spark gap so fine, the ozone disappears.
I mean,
But
the high voltage going across the coil, maybe it's creating a breaking up or
I don't.
disassociating oxygen molecules around it or something.
It could be, but I can't smell the ozone
Just
like
because you
I
don't
can do
see
on
a
the cell.
spark or nothing doesn't mean it's not, the high
It
voltage
could.
is not.
They say ozone like re-energizes, cells. They use it
Well,
like
what's
in
going on
video.
with the ozone is the O2 in the air is being split into two O's, and the two O's are singly or individually combining with
Yeah,
another O2 to make an O3. And that's happening through high potential.
right.
You know, that's
If
what's
you're,
splitting up the molecules is a higher potential.
yeah.
It's got to be
So
high
yeah,
voltage. I mean, it
and
already is high. We know it's high voltage. They use high
yeah,
voltage just to make ozone.
and what really made the difference as soon as I introduced the transducers, the barium titanate piezo transducers, that's when really things start happening. That
Okay,
was the
this
real
might
game.
sound funny, but I'll tell you this. You know where my electrical meter is? Like in the
Yeah,
house, in every house, or where the electrical wires run to the house. If
yeah.
I go sit there for, like you said, for like 10-15 minutes, I feel
Is
like
it
I have,
wireless?
no, it's it's like underneath the ground, but it has like a little thing that,
I mean, does the electrical company read the meter wirelessly?
no, it's a thing on the side of the house.
It has
Maybe
a
they
number.
do. Maybe they do, but
Yeah, we have
I
this now, like it
If it
mostly
does,
limited
because
now.
that I had an issue with my own meter. I had to buy EMF shielding tape, and
Yeah,
it was disturbing my
yeah,
sleep. I didn't
yeah,
know what it
60
was.
hertz is not
When and
good
it,
for
I
you.
figured it out. The electrical company came out and put the new meter in. I'm an electrician, so I'm like, hey, go ahead, man. You know.
Yeah, yeah, 60 hertz
And
is
they put
very
it in,
good.
and then like a few years later, I was just not having good sleep. I was like, what's going
Yeah,
on?
yeah.
And
Some people are really
I bought some that
sensitive.
tape, put it around the meter, just around the side of it, not the face of it. So if you put it
hmm
around the side, it
yes.
won't go outwards towards your rooms and stuff, but it'll go like out the face now, so they can still read it that way. But it won't
Okay.
go direct. It won't hit your rooms and stuff.
It's not overlooking the house. It's on the side of the garage facing away from the house. So,
Get the EMF tape, put it around the side of the meter, so the face is clear and
yeah.
facing away from the house, and they'll still be able to read it, and you won't be receiving any of those pulses
Yeah,
anymore.
because a lot of that energy is parasitic and
I
it's
was
not good
doing
for your
much better
body.
after I put it around my meter. Let's just put it
Yeah,
that way.
yeah. Some people are very sensitive to 60 hertz. It's really bad for you. Even 50 hertz is a better
It's not
frequency
60
for your
hertz. It's a
body.
pulse that it's a pulse
Oh, it's a
to read
pulse.
the meter. It's a
Oh, okay.
pulse signal,
Well,
and it comes like once a minute or something.
Oh,
okay.
wow.
You can't. Yeah, it's not, you can't hear it or nothing, but it does mess with your sleep, I think, because I correlated the timing with the new meter in my sleep patterns. And then I bought the tape, like I said, the EMF tape, put it around the meter, and my sleep got better, you know?
Yeah. Yeah.
So,
Very interesting. I believe it. I really do. Like one time I know somebody was messing with me to the point where any device that I plugged in, it was extracting the charge in it. So for example, if
you
I
see
was trying to
the meter itself is sending the pulse. So it's like too much energy coming from the, you know, it's your meter is sending the pulse out to them to read it. That's why you're getting a large signal, because your meter's making the pulse right there. It's right there at the meter, the pulse. You know, it's
let me
created
get a
right there.
light. Let me show you guys the meter. Let me try to get a light.
And they
Here.
don't turn it, they don't turn the dial down on that because they want to make sure they can read it. So
Yeah. Exactly. Well, it's probably a Wi-Fi signal that they use. I know
it is.
they
It's some kind of a, you know,
Yeah. Well, they have the
cellular
Wi-Fi.
pulse signal.
Well, we have the smart meters now. Most of Canada's.
You know, like they have the
pretty well.
same cellular pulse signals, you know, connections for your alarm systems. They work great, but they don't interfere with my sleep because those are tuned down. They don't have the amps up on that thing.
Yeah.
You know, they have it set right, you know. But the electrical company, they don't, they waste the power, you know, with
Oh yeah.
everything.
Of course.
So the pulse generator on that meter is putting out too much strength of a pulse, too much
Okay, this
amps
is my
behind it
meter.
probably.
This
Yeah,
is the
get the
meter.
tape, put it around the side
Oh,
of it.
you got the old one. Is that? Hold
Yeah.
on. Does it have a digital display on the front?
It's
Yeah.
probably read
Yeah,
wirelessly,
it's a
man.
smart. No, that's a smart
It's a
meter.
smart meter.
Yeah.
Yeah, you're getting that pulse hitting you at night while you're sleeping, messing up your sleep.
Yeah, but there's a
Probably.
garage. You see, it's facing away. My house is behind. This is the garage wall, what you see here.
It
Yeah.
doesn't matter. You're not hearing me. The face, yeah, it also comes out the face, the signal, but it also goes out the sides. And that's where it goes into your room from the sides. It goes into your
Okay.
house from the sides. It
Yeah,
doesn't
Okay.
go out. It doesn't go into your house from the face out when the signal goes out the face of it directly that way. No, it more likely hits the neighbor's house, not your house.
Yeah.
But
Lulu,
you
you're
know
in the
that's
States,
further
right?
away, so the amplitude is decreased, so it's not going to affect them. You know.
Lulu,
But
you're in the
the
States.
sides coming out the sides of the meter, and that's high amplitude pulse. It's gonna it's gonna hit the house as well. And if you put the tape around the sides, it'll block all that, and they'll still be able to read it because its signal's going out the face now instead of the
Lulu,
side and the
you
face.
live in the U.S.
I do. I live in the Woodlands, Texas.
Oh, okay. Oh, you're way down there.
Yeah, then
Yes.
it's definitely a smart meter because they don't want to walk all the way out there to read all the meters.
Yeah.
And they
Well,
actually
They
changed
can.
it recently, like about maybe a year ago. They
do you
came in.
remember? Do you remember the old meters where you had that disc spinning inside?
Yes.
Yeah, I have
Yeah.
one.
That's
I
what.
Okay.
still
Yeah.
have
That's
one.
what.
Well,
That's
that's an
what I
over
had. They
Unity
changed.
device. That was designed by Tesla. That's an over Unity generator inside that. Back in the old days, they didn't have the power transmission what we have today. So when Tesla designed that system, all the current was generated in that meter, not from the power company. All the power company provided was 120 volts at 1 amp.
Mm.
The amperage that you used in your house was generated right on the side of your house.
So basically, they swapped something, that was working really well and it benefited the consumer to something that now,
Well, basically, the consumer was getting screwed right from day one because all the
They're always
power
going to screw the
company,
consumer.
the power companies, all they were producing was a seed current just to get the device to operate and oscillate. The real power generation was done in that meter, which
ah,
was designed by Tesla.
so really, like, what were they charging us for? Just that, like, little bit to
Seed
get it to
Right,
start?
right. You got it.
Isn't
That
that
Oh,
meter,
isn't that thing in that
that
meter a
meter,
resistive load?
well, it's got two large coils, a primary and a secondary, and you have two small
That's a load.
magnets,
That's a
right?
load.
Right.
That's a
And
load.
yeah, so basically all it needed was 120 volts at 1 amp in order to get that thing to go into
And
oscillation.
anybody could have started it with just a battery. You didn't have to have all these wires in the ground where they,
Yeah, so all you needed to do was get it oscillating. As soon as you got it oscillating, the generator or the meter itself was the generator.
my
So
God,
all the
what a
I mean, what's the
rip-off.
60 hertz, you mean?
What a
yeah,
rip-off.
that's all it needed, a 60 hertz, 120 volt, 1 amp, and that was it. It was in oscillation and it was creating the current for your house. So what happened was, if say you had turned your air conditioning on, what would happen? The wheel would actually come to a stop. Okay, it causes the magnets to start slowing that wheel down and create a high frequency vibration. And if the house was under a heavy load of current, remember back in when I was a kid, that thing used to shake. It was rumbling. That was because it was generating current in the coil, because like either you turned your air conditioning on, or some high demand
Well,
inside
yeah,
the house.
you could hear it, vibrating. Well,
Right, exactly. So
it's
when it
not
went
loud
under,
or nothing. You got to really put your ear to it. But yeah.
oh, I could hear it from a good distance. I remember as a kid, I could hear it rumble in a way, and I knew it sounded like something major was going on inside that in that
Maybe
box.
this is a much older meter than the one
Oh
I
yeah,
have.
these were the old meters. These were the old ones that were designed by Tesla.
I mean, I have one that spins too. It spins, but
Yeah, the newer ones weren't like that. They changed down the road because, obviously the power companies got stronger. They were able to provide more power, and then you had those little substations
oh,
that would carry that
uh-huh.
current along. But back in the turn of the century, when this stuff was just coming online, they didn't have a robust system like they have today. So a
So
lot
you're
of that
telling me
work,
the new ones work like they have like let's say like a cell phone signal, and it would pulse like that signal to the power, to the energy company, and
right?
it. Oh,
Right. They charge you by the
wow.
kilowatt hour. See, back in the day, the current is what they really charge you for. So in the early days, in the early 1900s, when this power transmission was going out, they couldn't provide each house with 100 amps. They couldn't do it. So Tesla designed that meter to actually do that. But the part was, they were still charging you for the 100 amps. Meanwhile, it wasn't even generated at the power station. It was done on the side of your house.
That's what the sound was, the rumbling from.
Right. That rumbling, that's when it was going into high oscillation to create current. So, like, I'm
They
talking
don't
like,
they don't teach anybody the truth of
of
things.
course not. Of course not.
My gosh.
Yep. And I knew a guy years ago when I was a young kid. I overheard a conversation. He was talking to somebody about this, and he was talking exactly the same thing I'm talking about right now. He goes, "This thing is a generator. It's not just a meter. It's generating power." And I remember that.
What
So
if somebody actually went and bought these things
you can, you
and
can.
and and,
People have
and
done it.
attached them to the house where it generates electricity?
They won't allow you. The utility companies wouldn't allow you to do it. They would charge you for one thing,
How
because
would
you're,
they even know?
well, they would go on the side of your house and see it, right?
Well, yeah, I
Because you
mean,
have,
yeah, or you could have it inside of the house and plug it into one of the outlets, and you know,
yeah, exactly. Well, yeah, that's possible too, right?
yeah,
But I really don't see that happening, because they'll figure out, oh, why is this guy consuming so much less power now? You know what
yeah,
I mean? He'll become
yeah,
suspicious.
yeah.
So yeah,
Oh well, yeah. It's fun to experiment with these things, and then,
sure. I want to get a hold of one of those. I want to play with one. I want to see what I can do with it.
just don't get in trouble, or
Well,
don't,
no.
or don't let
Yeah,
them, don't let them
yeah,
see it. Keep them
exactly.
wondering, like, you know.
I'll keep it on an isolated circuit so they won't know.
You gotta have a main disconnect to disconnect from the grid when you have
I
these
guess that would be
Yeah,
running.
you gotta
cool
be.
if you were running like a cryptocurrency farm. That would be useful, you know, to do it that way. Like, because these things, like the the ant miners, like use so much energy. It would be really costly to But if you have something that's generating, and it's there's no theft in this, because you're generating your own energy. It's not like you're taking it from anybody, or you
Yeah,
know.
there's another guy out there, an older fella. He's got a YouTube channel. I don't know if I can find it, but what he's done, he's got a big property and he's got the high voltage mains
Hmm.
that go on his property. So what he did was he got a large cable, put it on a fence, and put it right beside in line with those power cables. And he was able to extract just by the flux that was coming off those high voltage lines. He was able to dump it into a high voltage capacitor and actually do experiments with it.
I
So he was,
always thought that those things resonated energy. I always
oh,
like
they
it
do.
made way
Oh, they
more
do. Big
sense.
time.
Yeah, like that there has to be, it has to be, putting off an electric field that somehow
Sure,
more
sure.
than just what's in the
What, the
wire.
transformers on the poles?
No,
Not just the transfer, even the wires, like all of it.
just the wires. Yep.
Yeah, that's what they call the heaviside component, that static field that builds up
Yeah.
Yes.
around the
Yeah.
You could go
coil.
beside one of those towers and you could probably stick a light bulb in the ground and probably light up a neon bulb.
Theoretically, I knew it made sense, but like today, you guys gave me like a
You suppose
confirmation.
those insects that have luminescence, they're using the same
No,
heaviside
you're talking
component?
about what? Well, you're talking about the fireflies.
Yeah, you know how they create light with
No,
electrochemistry?
that's electro
Yeah, but right, but what is this
chemical
static
reaction.
field that's being created around the wire? That's the same. It's still electricity. It's just not made with chemistry.
I
You
never
know,
thought about that.
Does it have to do with sunlight, converting sunlight into their chemistry to produce that?
the insects, they use chemistry to create the electricity, which then is automatically going to create the heaviside component because they already created the electricity with the chemistry. You need electricity for the heaviside component to exist. So
I
once
saw
it,
something a while ago. I can't remember, but but I do.
that static field can light up a fluorescent bulb. That's what I'm saying. So
Yep.
that same
Oh.
light that's emitted from a fluorescent bulb is the same, around about the same brightness as the luminescence coming from an insect light. It's the same brightness. It's not extremely bright. It's not dim. It's right about there, And it's just ironic that when you put a fluorescent bulb to a radiant field, it lights up to the same brightness as the brightness of an insect light bulb, like a light bulb creates, and it's light. It's the same brightness. So it's using the same static field to create that light. So when you put the fluorescent next to a static field, it lights up to a certain brightness, you know.
Yeah.
You can move the light around, it gets dimmer or brighter, but the brightest it gets is about the same brightness as the light that comes off of a light bulb
Anyways,
when
guys,
you look at it.
I'm gonna have to call it quits for tonight. I gotta be up early again. I gotta go back to the dentist again, get some more work done. I've been there like 10 times in the last 2 months. Get my teeth fixed. So he's almost done now. So I gotta get the last bit of work done tomorrow morning. But yeah,
Did you
so
get sore before you had to go? Did you feel sore in
I
your
just
tooth?
I got the benefits from work, right? So I'm using them.
Oh,
So
so you don't wait.
I
Yeah,
got my
like
my
take a couple of sips of whiskey before you go. You'd feel a lot better.
Mm, yeah, exactly. So next week we'll be doing another live show on March 22nd. That weekend is my birthday weekend, and then the 29th is Good Friday. So we'll be doing a show on the 22nd next Friday, and then the 29th we're going to take off. So because of the Easter weekend, Easter lands in March this year. So we will do the next live show after that on April 5th. So yeah, Mike, Lulu, thanks a lot for joining me tonight on this Friday night. We made a good show. We did a little bit of overtime tonight. That's always okay. And yeah, we'll see everybody next week. Don't forget to visit Mike's channel and also my channel at Faraday Research. Mike, if you want to put your link in the live chat, and everybody can check out your site as well. Lulu, do you have a site or?
I don't. I'm just a regular person that watches YouTube. I don't,
Oh,
I don't.
okay. That's okay.
One day, maybe.
Yeah, when you start doing some experiments and start your own YouTube channel,
Yeah,
Mike,
like you, not only experiments. I have like theoretical physics theories that
Sure.
I have so much documents to prove, how you can speed up time and how time dilates, and it's not what the clock says it really is.
Yeah,
It's stuff, different stuff.
yeah, you got to
But
talk to Philip about that. Yeah,
it all
you got to
ties in
talk to.
together. Like, what you said, like you started with one field, but then you started like a lot of other things tied into what you were searching for, and you
Right.
started learning different things.
Sure.
Well, that's how it started with me, but it all connects at the end because energy and time and
Yeah,
space, and it's still all
energy
one
goes in many
family.
different
It's still
directions.
in the whole one family of science,
Yeah,
honestly.
it goes into a lot of different dimensions. It goes into energy. It goes into time dilation. It goes into time travel. It
Goes
goes
into
into the
particle physics.
metaphysical, particle physics.
Yes.
Exactly. It goes
Yeah.
into so many.
Wormholes.
That's why. Uh, when you get into this stuff, you don't realize how big that rabbit hole gets until you're about halfway down, and then you're going, "Oh shit." Right?
like
So,
like my new thing is I'm trying to build that Kozarov mirror, but with a different twist. You know how he's got his the Kozarov mirror, how it goes into like a loop, it double loops. Well, I
yeah,
want to create it where it double loops on the opposite side, a continuum, so it looks like a big old S instead of just a circle. It
yeah,
continues from both sides, and the idea is you have two people in the center of these, and then two people outside, like need four stopwatches. The two people on the inside would be holding a stopwatch. The two people on the outside would be holding the stopwatch, and you measure it. You measure the time dilation between the inner and the
yeah,
outer. Yeah.
yeah.
So, yeah.
Yeah, it's just it goes the ideas in different directions.
Nobody has built it. No, nobody has built it yet. Nobody. This is a new concept. I searched it, so it would be something brand new to science.
There you go. There you
Yeah.
go. Your contribution.
Yeah.
Anyways, everybody, thanks a lot for joining us. We'll see everybody next week, and hope everybody has a great week. And oh yeah, St. Patrick's Day is coming up. Happy St. Patrick's Day to whoever who celebrates that. And yeah, everybody have a great night. Take care.
Good night. Good night.
Good night.
Like,
Good night.
Right.